guys, you are welcome back to Larbi Premium Consult. On this channel, we share educational content ranging from mathematics to accounting. Hello guys, you are welcome back to Larbi Premium Consult. On this channel, we share educational content ranging from mathematics to accounting. Larbi Premium Consult. On this channel, we share educational content ranging from mathematics to accounting.
Hi, so welcome back once again to our live session today. So today we're going to look at a practice question on quantitative methods to actually guide us on how to understand the concept in relation to quantitative methods for business. So if you just join us, do want to like the video and join, and share the video as well so that others will also get a benefit to join in that case. So let's start. Question number 1. If y is equal to 7x to the power 2x, find dy over dx. So we are asked to find dy over dx of this equation. So we have y to be equal to 7x to the power 2x. Before we can actually differentiate this, we need to get rid of the 2x. Okay, so how do you do that? We do that by introducing what? Log on both sides of the equation. So we're going to have log y is equal to log 7x to the power 2x. So once you're able to get this, the laws of logarithm tell us that if I have log of a number with a power, then the power can be the coefficient of what? The log. So that becomes what? So we have log y to be equal to 2x log 7x. So once you're able to get this, now we can actually what? Differentiate the function. So in this case, when it comes to differential of log functions, this is how we go. When I differentiate y, I'm going to get what? Dy over dx. So that becomes what? Dy over what? Dx. But because it's a log differential, we also divide by what? The original functions, y. And when we come to the other side of the equation here, which is this, okay, which is this, here to also become the product of what? Two functions. So we hold 2x, we differentiate what? Log 7x, and after that we say plus, and we come and hold what? Log 7x and differentiate what? 2x. So that becomes what? So we have what? 2x, okay, then differential of 7x going to result to 7. But because it is a log differential, we then divide by the original function. So the original function becomes what? 7x, okay, plus, because this is a product of two functions, plus, and then we'll come back and hold what? That of what? Log 7x, and we differentiate what? 2x. So what are we getting? The differential of 2x is going to result to what? 2. Okay, so at the end of the day, this is what we're going to get. The x here can cancel the x. The 7 can also cancel the 7 on top here, okay? So at the end of the day, we can also say that the whole of it is divided by what? 1. So we can multiply what? Y by the whole of this expression, 2 plus 1 log 7x to bracket 2, right? And then multiply dy over dx by 1. So we're going to get dy over dx, all right, to be equal to y into bracket 2, okay, 2 plus log 7x dot 2, meaning it's multiplying, okay? So therefore, we'll say that dy over dx should be equal to, but we know that y here is equal to what? 7x to the power what? 2x. So we can actually place, in place of y, we can substitute 7x to the power 2x. So we can say that here should becomes what? 7x to the power 2x, okay, into bracket 2, all right, and we can bring what? The 2 here plus 2 log 7x, showing that it's multiplying. And this is what you're going to get at the end of the day when we differentiate log of this function. So let's take note of that. Do want to share the video and then like it as well. Okay, question number 2. We are asked to differentiate y is equal to what? 4x cubed plus 13 all to the power 4. This is the simplest way to go. So here we have y to be equal to, into bracket, 4x cubed plus 13 to the power 4. So how do we go here? What I want to do is first of all differentiate what? The power. First of all differentiate the power. So this is what we're going to do. We say that dy over the x should be equal to, you bring the power in front of what? The whole of this function. So the 4 will be here. Okay, so after bringing the 4 down, the next thing is to differentiate what? The terms in the bracket one by one. So differential of what? 4x cubed should fetch us what? 12x squared. So we multiply the 3 by 4 and we subtract 1 from the 3. So that becomes, so into bracket, 12x squared. Then differential of what? 13 is a constant, should result to what? 0. So we don't take that one into consideration. And after that, we repeat the whole function again, which is what? 4x cubed plus 13. Then we repeat the 4 and then subtract 1 from what? The 4. So I don't know, they will say that dy over the x should be equal to, so you can see that we multiply the 4 by the 12x squared. So that becomes what? 48x squared into bracket 4x cubed plus 13 to the power what? 3. We can also have this as our answer. In other tests, you might see, if it's an MCQ type, you might see something like this as an option. So that becomes 4 into bracket 12x squared into bracket 4x cubed plus 13 to the power what? 3. You might see that in that line. So anyway, just have to take note of that. Question number 3. A car dealer sells 2 brands of cars, Hyundai and Toyota, and 3 models for each of the brands. Which are sedan, pickup, and then coupe. The inventory of cars is shown below. So we have what? So these are the inventory of the cars for Hyundai and then Toyota and its brands, which are what? X, P, and then C. Okay. And it tells us that if the dealer makes sales the following month as given by the table below. So this is a sale that the dealer has made. Find the new what? Inventory. So what is happening here? We have the inventory, old inventory in stock to be this. And then the dealer has made a sale for a particular month and which was given us what? This. So the question asks how much of the inventory of Hyundai's and Toyota brands is what is left. Okay, so here we need to convert this whole table into what? A matrix form. This is an application of a matrix. So I will say that we have what? Our old inventory, OI, to represent that, and that should be what? So here it is more of what? A 2 by 3 what? Matrix. 2 rows, 3 what? Columns. All right. So that's going to give us what? 5, 3, 2. Then we have what? 8, 4, and then 1. So that becomes our old inventory in stock. And this is what we have made as sales. So I represent that as what? As sales. I hope I can be heard loud and clear. Sales, which is what? So the sales is what? 1, 2, 0, 3, 0, 1. Okay. So once you have the inventory we're having in stock and once you have the sale, for us to know what is left, you have to subtract the sales that we made from the inventory at the beginning of the period so that whatever is left, we get our new inventory in stock. So I represent that as what? New inventory. So what are we doing? We are subtracting the sales from the old inventory, right? So here it is more of what dealing with what corresponding what entries. So we just have to what, subtract 1 from what? 5, 2 from 3 in order to we are done. So our new inventory then is going to give us, so when I subtract 1 from 5, I'm getting what? 4, right? I'm getting 4. Then 2 from 3, I'm getting what? 1. Then 0 from 2, I'm getting 2. Then we come back to this, the second what? Row. So 3 by what? 3 taken from 8, I'm getting what? That of what? 5. Then 0 from 4, getting 4. And then 1 from 1, I'm getting what? Sorry. I'm getting what? 0. I'm getting 0. So this then becomes the new inventory in stock after the sale of what? 1, 2, 0, and then those kind of, Honda. So let's take note. So this is actually the application of what? Metrics. Question number 4. if the determinant of the matrix 2x 35 is equal to 13, find the value of x. So here, the determinant of this matrix has been given as what? 13. So we are asked to find the missing value, which was what? X, or the missing entry here. So how do you find the determinant of a 2 by 2 matrix? It is a product of what? Downward what? Arrows or downward values compared to the product of what? Upward what? Values. All right. So that becomes what? Into bracket 2 multiplying 5. Okay. Compare that to, by comparison, subtract, compare that to 3 multiplying x, and that should be equal to what? 13. Okay, so we have what? 10 here, we have 3x here, and that should be equal to what? 13. Okay, so you want to make as a subject. So all I want to do is to say that 10 minus 13 should be equal to 3x. So when the 13 joins the 10, it becomes negative, and when the 3x move back to the at the side of the equal to, it also becomes what? Positive. So we are getting what? So you are going to get to a negative 3 to be equal to what? 3x. Divide both sides by 3. Therefore, we can say that our x should be equal to what? Negative 1. So this is how we find the determinant. And then if there is any unknown value, you also deal with that in that case. Then question number 5. Question number 5, we are asked to evaluate the integral sign x cubed minus 3x plus 1 over 2 x squared dx. So by evaluation of this, we want to integrate this function back to its original form. So this is just a first differential. Okay, so this is what we're going to do. We will say that our integral or elongated x into bracket s cubed minus 3x plus 1 over what? 2x squared or dx. Because of what? 1 over 2x squared, we can write 1 over 2x squared as this before we start with the integration, right? So this is what we can do. We can say that here becomes what? S cubed minus 3x, okay, plus. So we can write this as what? 1 over 2. Remember, this x squared can also be written as what? X to the power negative 2 dx. So if I have 1 over x, it's the same thing as what? X to the power negative 1. If I have 1 over what? X squared, it's the same thing as what? X to the power negative 4, 2. So that's what we have actually done here. So once you're able to get this, then you can actually what? Integrate the function, right? So when I integrate x cubed, I'll add 1 to the 3 and then divide the result by the whole function. So that becomes what? X to the power 3 plus 1 divided by 4 minus here to 3x 1 plus 1 divided by 2. Then here too, I'm going to have what? 1 over 2 x to the power negative 2 plus 1 divided by what? So the result is going to result to a negative 1. Because it's an indefinite integral, we introduce constant, say c. Okay, so at the end of the day, we can write the whole of this as, so here becomes what? 1 over 4 x to the power 4 minus 3 over 2 x to the power 2. Remember, here is negative, so we will change this to what? To change this positive to what? Negative. So that becomes what? Negative 1 over 2 x to the power negative 1 plus what? C. You can have your answer in this form, and then you are good to go. So let's take note of that. Question number 6. The total cost per day, that is cost in hundreds of cedis for manufacturing X tons of steel, is given by, so we have the cost to be what? 3 plus what? 10x minus s squared, where we have 0 less or equal to x less or equal to 5. We are asked to find the marginal cost if x is equal to what? 3.5 units of level of production. So we have the cost and we are asked to find the marginal cost. So marginal cost is a change in what? Is a change in cost. Marginal cost is a change in cost. Okay, so to find the marginal cost, this is what we're going to do. We have to differentiate what? The cost function for the first time. So we'll say that cost prime of x should be equal to the marginal cost. And that should be what? So the differential of 3 should result to 0. Differential of 10x should fetch us what? 10. Okay, and differential of what? Negative x squared should fetch us what? 2x. All right, so once able to get this, that becomes my marginal cost function. So when x equal to 3.5, what will be the marginal cost for 1? But marginal cost, we're talking about the cost of what? Additional cost of 1. So we'll say that marginal cost should be equal to 10. Whenever I see x, I'll substitute what? 3.5 there. So that becomes 2 into bracket 3.5. So I'm going to get 10 here. I'll get 7 here. And I'm getting what? 3 here in that case. So let's take note of that. Question number 7. Find the derivative of the function f of x equal to negative 8x squared minus 4 cos x minus 4 cos x. So how do you find that? So here we say that the first derivative, that is f prime of x, should be equal to, so differential of what? Negative 8x. So here it's going to result to what? 8 multiplying to x squared minus 1. All right. And here is a product of two functions. So we hold for, we differentiate cos x. After that, we say plus, and we come and hold what? Cos x, we differentiate what? 4. So we have 4 here. Then we want to differentiate what? Cos x. So differential of cos x is going to fetch us what? Sine x. But here it's going to be a negative what? Sine x. When you differentiate cos x or cos of any variable, we get what? Negative sine of that particular variable, in this case x. Okay, then after that we say plus, and we come and hold what? Cos x. Differential of 4, right, is actually what? A constant, so that's going to result to 0. So 0. Then you close the bracket. So I know that we are getting what? Negative 16x. Then you have negative here, into bracket, negative 4 sine x. So when two negatives meet, actually result to positives, we're going to get negative 16x plus 4 sine x. Then you are done. So this is how you should be able to differentiate the function of this kind. So let's take note of that. Question number 8. If a is equal to this and b is equal to that, so their matrices actually, we have to find the values of p and q. Said that ab is equal to p1 negative 3 4 plus 3 multiplying what? Matrix negative 1 negative 3 7, and then q. So before you can actually get the values of p, you must find what? The product of what? A and b as being what? A matrix. Okay, so that's what you need to do. So in this particular case, we'll have what? We need to find what? A, B. So A multiplying B would have what? So we're going to have what? Negative 2, 4, 5, 3, multiplying what? B, which is 3, negative 2. Then we have 1, negative what? 3. So actually, this is actually what? Product of or multiplication of what? A 2 by 2 matrix. All right. So here, first row of the first matrix, first row of the first matrix will multiply what? The first column of the second matrix. And the same first row also continue to multiply what? The second row, second column of the second matrix. So all I want to do here is that we'll have what? A big array. So the two will first multiply the 3. We are getting what? Negative what? 6. Then after you say plus, then you bring the 4, also multiply what? The 1, and we are getting what? 4. All right. After that, you same what? Row of the first matrix multiply what? The second column of the second matrix. So we'll have what? Negative what? Negative 2 multiplying what? Negative what? 2. So that's going to give us what? Negative positive 4, sorry, positive 4. And then the 4 also multiply negative 3, and we are getting what? Plus negative what? 12. Okay, so that will help us to get the entries for the first what? Row of this what? Matrix. Okay, so once you're able to get that, then we'll come back to what? The second what? The second row of the first matrix, also doing the same multiplication of the first what? Column and the second column of the same second what? Matrix. So 5 will multiply 3. That will bring the entry. So 5 multiplying 3, we are getting what? 15. And 3 multiplying 1, we are getting plus what? 3. And then 5 will multiply -2, you are getting what? -10. And 3 will multiply -3, we are getting negative what? 9. So once you're able to get this, therefore, we can say that we will have our matrix 6 and 4 will fetch us what? -2. Then here we're gonna get what? -8. Okay, and then here we get 18, and then here we get what? -19. So once you're able to get this, then we can now compare this matrix as AB to this so that we can find what? Our values of P and then Q. So once you have gotten that, then we can say that here from this, let me equate it here. I will have what? -2, -8, 18, -19, right? So this is what we're going to do. I'm comparing this to this. So you see the P where it is, right? So there's the entry for P. So mean that its correspondence is going to what? That of what? Negative what? 1 and that of what? -2. But remember, we have a scalar multiplication of what? 3 here. So you also need to take note of that. So in this particular case, this is what we're going to do. We'll say that for us to deal with the P first, that should be what? Let me create a space here. That should be, so we will have what? Our P, all right, plus, remember that 3 will multiply the -1, so that makes it what? Negative what? 3. That makes it what? -3. So P plus negative what? 3, okay, should be equal to what? Negative what? 2. Or we can see that, all right. So once you are getting that, then we can see that P should be equal to -2 plus 3, okay, because here is -3, so when you join the 2, we count plus. Therefore, we can say that P should be equal to what? 1. So once you get P, P is also equal to what? 1. And then we come back to the Q. So the Q is also having what? Entries from, looking at this entry, we can compare Q to that of what? 19 and that of what? 4 here. Or we can see that, but remember the 3 is a scalar multiplication, so that should multiply all the entries in this matrix. So you don't forget that. So here we can write an expression for Q2 to be, so let's see. So in that line 2, we can say that we'll have what? We'll have -4, okay, -4, okay, plus 3Q, plus 3Q, and that should be equal to, what? -19. So at the end of the day, we'll have 3Q to be equal to -19. Remember, this is -4. When you join the -19, you get what? Positive. So plus what? 4. So 3Q should be equal to what? -what? 15. Divide both sides by 3, then we get Q to be what? -what? 5. So therefore, our P is equal to 1 and our Q is equal to what? -5. So let's take note of that. Then question number 9, find the determinant of the matrix. So here we have to find the determinant of this matrix. This is actually a 3 by 3 matrix. When we get to some of the questions, I'll use calculator to practice some of how you use calculator to practice some of them so that you get to understand. In any case, you have any exams, you can use a calculator to work it well in the best way so that you are good to go. But once you get the concept right, it becomes so simple for you to actually go. So we have to find the determinants of this matrix. So this is a 3 by 3 matrix. So all that I want to do is that you have to repeat this matrix again. So we'll have what? Matrix A to be 3, 2, 1, 4, 0. Please do all to like the video and share it as well. Do all to like the video and share it as well, and subscribe to the channel as well too, right? Then we have here to be -1, 7, and then -2. So if I want to find the determinant of this matrix, all that I want to do here is that I'll repeat what? The first two columns of the original matrix A. So that becomes what? 3, 2, 1, and we have 4, 0, -3. So once I repeat that, then I introduce my upward arrows and downward arrows. Okay, so this is what I'm going to do. I'll indicate my downward arrows. So where I get a diagonal of a 2, 3 values I indicate. So also indicate 1 from here, the 4, 7, and then the 1. Okay, and then 1, 2, and then the -3. So that becomes my downward arrows, and then compare that to the upward arrow. So we have 1, 0, 1, and then negative 1. We have negative 3, 7, and then positive 3, and we have what? Negative 2, 2, and then positive 4. So after doing that, the next thing is to what? Find the product of what? These what? Valued arrows. I mean the arrows in here. So what is the product for? Let's do the downward first. So 3 multiplying 0 multiplying negative 2. Any number multiplying was 0 is 0. So that is off. Then we come to 4, 7, 1. What are we getting? We are going to get what? 28. All right. Then negative 1, 2, negative 3. We are getting what? Negative 6. After that, you deal with what? The upward arrows. So if you have 1, 0, negative 1, we are getting 0. Because of the 0, we get 0. Then we have negative 3, 7, 3. We are getting what? Negative 63. We are getting negative 63. Okay, and then lastly, we have negative 2, 2 and 4. We are getting what? Negative 16. So after that, then this is what you need to do. You will then need to add what? The product of what? The downward arrows, and then compare that to the product of what? The upward arrows. So therefore, our determinant of matrix A should be equal to what? 28 plus 6 plus 0, a number plus 0 same as the number, right? Minus negative 63, negative 16. So here you're gonna get what? 34. You're gonna get gonna get here to be negative, and you get negative 79. So when two negative meet, you get positive. So 34 plus 79, you should be able to get what? 113. 113. So that becomes the determinant of this matrix actually. If you want to actually use a calculator, you need to actually get the matrix on your calculator. So you go to your mode and then you select matrix. Once you select matrix, you actually see, let's see if I can show you my calculator if it is possible. Let's see, I'm coming. Let's continue. I'll do that when we are getting close to the end of the discussion for some of the questions so that you appreciate how it goes. Question number 10. The function f of x is equal to x squared minus 3x plus 7 has a turning point at, so we have what? F of x to be equal to x squared minus 3x plus what? 7. So you're talking about has a, so we're talking about a turning point. So we need, or we want the value of what? X. So how do you get that? You get that by what? First, find the differential, the first differential of the function. So that should be what? F prime of x. And that should be equal. So the differential of what? X squared should fetch us what? 2x. Differential of negative what? 3x should fetch us what? 3. Okay, and differential of 7 should be equal to 0. At this point, you should be able to know how to differentiate without difficulties, right? You multiply the coefficient by you multiply the power by the coefficient or by the function, and then subtract 1 from what? The power. So at the end of the day, we know that at first differential, our f prime of x or dy over dx is always equal to 0. That's the point where the curve or the function is at rest. So we would therefore say that if f prime of x is equal to 0, then we can say that 2x minus 3 should be equal to 0. Okay, and then we solve for x. That should be equal to what? Positive 3. We divide both sides by 2. We divide both sides by 2, and we are getting x to be equal to what? 3 over 2. And that is all. Or better still, you say that one whole number 1 over 2. 1 over 2. So let's take note. Now, question number 11. Given that y is equal to 5 with exponential function 3x plus sine x, we are asked to differentiate this function. We are asked to differentiate this function. So how do you go by this? You also say that here too, your dy over dx, your dy over the x should be equal to, your dy over the x should be equal to, so here you first have to differentiate to the exponential function 3x. So differential of 3 is going to fetch us for 3, right? So once you get that, you multiply that by the coefficient of the exponent, right? And that's going to result to what? 15. So we get here 3, multiply by 5, you are getting 15. After that, you repeat the whole of what? The exponential function. So that becomes what? exponential function 3x. Okay, and then you come to the sign x. So we said the differential of sign is going to result to what? Positive what? Cos x. So we say that plus. We say that plus cos x, and we are done. Simple. So this is how we differentiate this kind of function. Question number 12. If matrix kk 4k plus 2 3 negative 1 k is equal to 6, find the value of k. So here, when you see something of this nature and you can see these bars, that tells you that actually we want to find the determinant of what? The matrix. But before we can do that, we need to what? Add what? These two what? Matrices. After that, we'll find the determinant of these two and then equate that to what? 6. So actually the determinant of this is actually what? 6. So here is what we're going to do. K plus 2 is going to what? K plus 2. Okay. And then here too, we have what? K plus 3. We are getting what? K plus 3. Then we come back to what? Next. So 4 plus negative 1, we are getting what? 3. And then k plus k, we are getting what? 2k. So once you're able to get this matrix, we then have to equate that to what? 6. Meaning that here is the determinant of what? This what? Matrix. So to find the determinant of a 2 by 2 matrix, all that I want to do is multiply this downward what? Arrows, compare that to the upward what? Arrows. So we'll have what? 2k into bracket k plus what? 2. And then compare that to 3 into bracket k plus what? 3, and all should be equal to what? 6. And all should be equal to what? 6. And all should be equal to what? 6. Okay, so now we have to deal with what? The bracket. So when you multiply 2k by k, we are getting what? 2k what? Square. Then 2k plus multiplying 2, we are getting 4k. Okay, minus, and then we deal with this one too. So we have what? To bracket 3k plus 9, and that should be equal to 6. So let me bring it at the top here. So we therefore say that we'll have what? 2k squared plus 4k. And remember, the negative is going to affect the bracket here. So we get what? Negative k, negative 9. So that's going to give us negative 3k, negative 9, and that should be equal to what? 6. Okay, so at the end of the day, this is what we're going to do. 4k minus 3k will get us what? 1. So that's going to be what? 2k squared plus what? K minus 9. But remember, here the 6 can join the 9, making it what? Here is negative 9. When 6 joins the negative 6, negative 9 becomes negative 6. And that will fetch us what? Negative what? 15. And that should be equal to what? 0. So when you get this, let's see if I can bring my calculator. Where is it? Yeah. So once you get this, then on your calculator, this is what you're going to do. You go to mode, right? You press 5 on your calculator and then you identify what? An equation as square, an equation as square plus bx plus what? C, and that should be equal to 0. So this mine. So once able to get mine, this is what I'm going to do. The coefficient of what? X squared, which in this case is k squared, should be what? 2. Okay, just press when you feel it. Let me see if I can zoom it and make it big for you. Okay, so we have 2, and then the coefficient of what? X is what? That's b is what? 1. Okay, and then that of c is what? Negative 15. All right, so once you're able to get this, then you press equal to sign. So you press equal to sign, you get first your x to be what? Negative. So here in this case, it's going to be k. So we'll have k. I'm going to reverse it. Since it is equal to negative 3, when I reverse it becomes what? Positive 3. All right, I put a bracket in it, and then the second x is what? In this case is what? 2.5. So I also have what? K, which is positive. So that becomes what? K, and I reverse it, it becomes what? Negative 2.5. and that should be equal to 0. This is all you need to do when it comes to the theory part. You don't actually factorize by going through the whole process. So therefore, we'll say that our k should be equal to -3, comma, positive 4.25. Positive 2.5, sorry, positive 2.5. And you are done. So here you need to be very smart and sharp. Once you get a determinant, get a quadratic fast, and then use the calculator to get the values, and you are good to go. Question number 13. Differentiate implicitly with respect to x. Please do all to share the video, like it as well, so that others will get a benefit also to drop in and then join to learn with us. You have to differentiate implicitly with respect to x. So you have xy plus 2y to be equal to what? X squared. So how do you differentiate this? So this is the function xy plus what? 2y is equal to x squared. So by implicit function, it actually has to do with what? Two or more variables being combined by what? A multiplication. So here, this is what I'm going to do. Since this is a product of two functions, I'll hold x, differentiate to y, and I'll say plus, and I'll come back and hold y, differentiate what? X. So this is what I'm going to get. I'll hold what? X, and I'll differentiate what? Y. Differential of what? Y. If it is respect to s, it becomes the y over the s. If it is respect to any other variables, it becomes the y over that what? Variable. So I'll hold x and I differentiate y, and that becomes what? Dy over what? Dx. Then I'll say plus, and I'll come back and hold the y, and then differentiate x. Differential of x should fetch me what? 1. Then I'll move on to that of what? 2y. So here's the product of two functions. You just have to hold the 2, differentiate y. What are we getting? So that becomes plus 2. You differentiate y, becomes what? Dy over dx. Then you say plus, you come back and hold y. Differential of 2 is what? A constant. That's going to result to 0. That's why most of the time we don't bring that. All right. So I can, because it's going to result to 0, I can ignore that and then move on to say that here should be what? Differential of what? X squared should fetch me what? 2x. Okay. So at the end of the day, that's what I'm going to do. I want to make what? Dy over the x the subject. So it becomes what? Dy over the x. I have x here, I have 2 here. So I'll bring them into brackets. X plus what? 2. Okay, and that should be equal to 2x. Remember, we have y multiplying 1 here. That also will join what? The 2x. So that makes it what? Negative y. So since I want to find dy over the x, I'll divide both sides by x plus 2. Divide both sides by x plus what? 2. Okay, so therefore, my dy over the x is going to give me 2x minus y divided by x plus what? 2. And I'm done. Very simple. Okay, question number 14. This equation is not here. Okay, I'll come back to that. I don't know why I don't have it here. So let's move on to question number 15. Given that this matrix 3x plus 1, 7, 2x plus y, 3, and we have 10, 3x minus y, and then 8, 3. We have to find the values of what? X and then y. So here too also has to do with corresponding or comparing of what corresponding what entries, right? So what I want to do here is to compare 3x plus 1 towards the first entry of the that comes after equation, which is what? 10. So we'll say that 3x, okay, plus 1 should be equal to what? 10, so that we can find x. So what are we getting? 3x should be equal to 10 minus 1. Okay, and we are getting 3x to be equal to what? 9. So therefore, x should give us what? 3. Because we divide both sides by 3, get 3 in that line. Okay, so once you're able to get 3, that's fine. You can move on to find what? Your y. You can move on to find what? Your y. So y2, just have to look at the corresponding entries based on this, and then you find y. So I can also find y from here, the 3x minus y compared to that to what? 7. Okay, so in this case, I will say that 7 should be equal to 3x minus what? Y. Then I want to find what? Y. But remember, we know that x is equal to what? 3. So whenever I see s, I will substitute 3 there. So that becomes what? 3 into brackets 3 minus y. Okay, and we should be able to get here to be 7, here to be 9, here to be negative y. So when the negative y find itself here, that becomes positive, and then you have 9 minus what? 7. So I'll bring the negative y here to take the place of 7, and then the 7 also join the 9, making it what? -7. So I don't know, they will say that y should be equal to what? Positive what? 2. Y should be equal to positive what? 2. So therefore, our x is equal to 3, and our y is equal to what? Positive 2. So let's take note. Then question number 16. The marginal revenue in cedis per unit for item is for a revenue function, which is equal to our revenue prime of x, was giving us what? 300 minus what? 2x. 300 minus what? 2x. But we have to find the total revenue from the sale of what? 100 what units. So you need to convert the marginal revenue to what? A total revenue. How do you do that? We need to integrate it so that we can find our total revenue function. So in this particular case, we will say that we introduce our elongated what? X to mean the integral, right? So when I integrate what? Marginal revenue or r prime of x, I will get what? My revenue what? Function of x. Then when I integrate 300, means I'm going to get what? 300x. Okay. When I integrate what? Negative 2x, that becomes what? Negative 2x. 1 plus 1 divided by what? 1 plus 1 is what? 2 divided by 2. And because it's an indefinite integral, we introduce a constant, say what? C. Okay. So once you're able to get this, then you and I know that when we're learning the concept of integration in relation to business or business word applications, we learn that at the production level of 0, three things will happen. When production level is equal to 0, our variable cost will always be equal to 0. Our total cost will always be equal to our fixed cost, and then our revenue will always be equal to what? 0. But where we don't produce, we don't get any unit that you will sell to what? Actually make what? Revenue. So where production is 0, we don't get any revenue. Revenue is what? 0. So we'll make an assumption that at the production level of 0, our total revenue should be equal to what? 0. So we say that when x is equal to 0, our r also should be equal to what? 0. That's what we're going to say in that case, so that we can find what? C. So in this case, here should be equal to 0. Whenever I see yes, I'll substitute 0 there. So we have 300, 0 minus here, the two cancel. So I'm having what? 0 x squared plus c. So mean at the end of the day, your constant is also what? 0. Because here, the whole of this is going to fetch as 0, and you have here 0 to be. So here, meaning that our c is equal to what? 0. So once we get that, then we can say that our revenue function proper should be equal to what? 300x minus what? X squared. 300x minus what? X squared. So let's take note. So once you're able to get this, then we can find the total revenue when we have sale of what? 100 what? Items. So that should be equal to what? 300. Whenever I see as I'll substitute what? 100 there. So that becomes what? 100 minus. So you also have here to be what? 100 or what? Squared. So what are we getting here? What are we getting here? Here you should be able to get what? 30,000. Okay. Then minus here, you should be able to get what? 1,000. You should be able to get 1,000. When you take the difference between the two, you should be able to get what? 29,000. So mean that the total revenue of 100 items will fetch us for 29,000. Question number 17. If the marginal cost function for a month for a certain product is 30Q plus 50, where Q is the number of units and cost in cedis, if the fixed cost related to the product amount is 100 cedis, find the total cost function. So as we dealt with that of what revenue, same way we can also deal with what the cost. Always note that when you make assumption that at the production level of 0, three things will happen. Your variable cost should be equal to 0. Your total cost should be equal to your fixed cost, and your total revenue should be equal to what? 0. I have a video that explains that concept better. You can watch that on the channel. called integration with business application. You can look at that later. So here we are asked to find the total cost what function. So total cost function or the marginal cost function is actually the differential of what the total cost function. So our total cost function, which is the differential of x, so here it's actually what q, so we just use q, should be equal to what our marginal cost, and that in this case it is equal to what 3q plus what 50. Okay, so we need to actually integrate what this function so that we get our total cost function back. So by integral, we just have to introduce what your integral word or integration sign. So when I integrate marginal cost, I get total cost. So total cost of q. So the integral of what 3. So if you've actually been following the discussion better, you clearly see that it's all about differentiation, integration, and it's actually very simple. If you are integrating, we add and divide. If you are differentiating, we multiply and then subtract. So here, I'll add 1 to the power here, making it 2. So that becomes what 3 over 2 q square. Now here to our attach 50 what? I'll attach q to the 50. So that becomes what 50q. And because this is an indefinite integral, we introduce a constant, say c. Okay. So remember, this is a total cost. Remember, total cost is a combination of what? Total variable cost plus total fixed cost. Total cost is always a combination of what? Total variable cost plus total fixed cost. And you know from the question that we're given the fixed cost. If the fixed cost related to the product amount is what 100 cedis, then we have to find the total cost function. So here you also make our assumption that at the production level of 0, right, where we have our production level to be equal to 0, our variable cost is 0, our total cost equal to our fixed cost, and our total revenue is equal to 0. But here we're going to be interested with the total cost being equal to what the fixed cost, because production level is what 0. So meaning that total cost here would then be equal to the fixed cost, which in this case was giving us what 100 what 100 cedis. So we'll have what 100 cedis here at the production level of 0, and we have what 3q. Whenever you see, you have 3 over 2. Whenever you see q, substitute 0 there. So we have what 0 square plus 50, 0 plus c. So meaning that here is 0, here is 0. So meaning that c is actually what 100. So the constant is actually becomes our fixed cost, where the production level is what 0. So therefore, our total cost function of q beta should be equal to what? That of what 3 over 2 q square, okay, plus 50 what q plus what the c, which is what 100. So this becomes our total cost function, because at the production level of 0, our total cost goes to our fixed cost. That is the assumption we are using here, and that will help us to find our total cost function. Question number 18. If M is equal to 3 by 3 matrix, and then we have N also being a 3 by 3 matrix, we are asked to find what? 2M plus what? 3N. So here, it is actually what? A scalar multiplication. So by scalar multiplication, you multiply the scalar by each entry or each element in the matrix. Very simple. So this is what we're going to do. We'll say that our 2m plus 3n should be equal to, so here we'll have to take the 2, multiply each entry in the matrix here. So what are we getting? So when we multiply 2 by 1, we are getting 2. So we'll first of all have this. So 2 by this, we are getting what? 2. 2 by 2, you are getting 4. 2 by 5, you are getting 10. Then here, you are getting 12. You are getting what? 6. You are getting what? 8. Okay. Here we are getting what? 2. Here we are getting what? 0. Here we are getting what? 4. Okay. All right. So once you're able to get that, then we can also deal with what? That of plus the 3n multiplying what? Matrix what? N. So the same thing, 3 multiply 1 in that order. So we exhaust what the entries in the matrix there. So 3 multiplying what? 1, we are getting what? 3. Then we are getting here 0. We are getting here 3. We are getting here 9. Okay. We are getting here 9. We are getting here 9. Here is what? Negative 3. And then here is what? 6. Then here is what? Negative 12. Here is negative what? Sorry, positive 9. And then here is what? 3. So once you're able to get this, then we need to just be adding the corresponding what entries. So what are we getting? 2 plus 3, we are getting 5. 4 plus 0, we are getting 4. 10 plus 3, we are getting what? 13. Then 12 plus 9, we are getting what? 21. 6 plus negative 3, we are getting what? Positive 3. 8 plus 6, we are getting what? 8 plus 6, we are getting 14. Okay, and then here to get what? Negative 10. Here plus this, we are getting 9. Then 4 plus 3, we are getting what? 7. So this becomes what? The end result for the matrix when we multiply 2n plus 3n in that line. So let's take note of that. Now, question number 19. Determine the values of x and y. Said that. So it is actually a matrix multiplying what? A vector, and that result towards a vector. So we need to actually convert this vector matrix multiplication toward a simultaneous so that we can find the values of what? X and y in that case. Okay, so this is what we're going to do. We will say that here the same thing, more like what? A 2 by 1 what matrix. So 2 will multiply the x, then negative 3 will multiply a y. Then after that, we come and do same here. Negative 1 multiplying x, 0 multiplying what? Y. So this is what we're going to do. We say that 2 multiplying x, we are getting what? 2x. Then we'll say plus, and then negative 3 multiplying y, we are getting negative 3. So plus what? Negative 3y. Okay? And then we come back to the second what? Row of this first matrix. Negative 1 multiplying x, we are getting negative x. 0 multiplying y, we are getting what? 0. So here becomes what? Plus 0. If you like, you can ignore, and then equate that towards 2 and then negative what? 5. Okay, so at the end of the day, we'll have what? Our 2x minus 3y to be equal to 2 as being equation 1. And we can solve for our negative x plus 0 is the same thing as negative x, and that should be equal to negative 5. So therefore, x equal to what? Positive 5. So once you get x equal to positive 5, then we can find the value of y from this equation. Okay, so since we know x equal to 5, we can say that therefore 2 into bracket 5 minus 3y should be equal to what? Positive 2. Should be equal to positive 2. So what are we getting? We get here to be 10. Here is 3y, here is positive 2. So I will say that 10 minus 2 should be equal to what? 3y. The y will come and take the position of the 2, and that will make it positive. And the 2 will take the position of negative 3, that will make it negative. So you're going to have here to be 8, here to be what? 3y. Divide both sides by 3. We are getting what? Y to be equal to 8 over 3, or better still, 2 whole number, 2 over what? 3. And that should be equal to what? Y. So if x equal to 5, our y is equal to 8 over 3, or 2 whole number, 2 over 3. Question number 20, we have to find what? We have p and then we have q. You have to determine what? P square and then q square. So here is the same thing. You must multiply what? P as being the matrix by itself twice, and also multiply the q by itself what? Twice. Okay, so once you get that, you can, so let's see if we can use calculator to do this. So with my case, I'll pick my calculator. Okay, let me go to my math mode. I'll pick my calculator here and then go to what? Mode, and then locate what? Matrix. So this is my matrix. So this is a 2 by 2 matrix. This is what I'm going to do. Oh, come on, where is it? Mode, matrix. Okay, so once I get my matrix, I'll press shift and then locate matrix here, which is what? 4, and then key in my value. Okay, so let's go for p and then q. P is what? 2 negative 4 3, so shift plus 4. So I'll go to edit because I've been using it for a quarter. That's why you see some figures there. So let me edit this figures. So this is a 2 by 2, so we'll have the first entry being 2. So 2, press equal to sign, then negative 1, press equal to sign. Then we have 1, press equal to sign, and we have 3, press equal to sign. So once you are done with the entries, just press AC. Okay, and then press shift, you press 4 on your calculator, you go to matrix B. that one too, we need to edit from here. So the B is going to be for the Q part. So we have 5 for the first entry, we have 2. For the next entry, we have -4. For the third, and we have what? 0 for the fourth entry. So once you're also done with that, you press AC. Okay, after that, you press Shift, you press 4, and you locate your matrix what? A. So in this case, your matrix A. So once you locate matrix A, which is what? 2, -1, 1, 3, that you see here, okay, which is here, all I want to do is to square it. All right, since we are talking about minus, you bring your minus and press what? Shift and go to 4, and then locate your matrix what? B, and that will also come up, and then you square it. When you square it, you get your final answer to what? -4, oh sorry, -14, -15, 25, and what? 16. So this is how you use calculator to actually to solve it. It's very simple in that line. It's very simple. So by doing that, if I want to know that of what my matrix A square, that's what I'm getting. I'm going to get what? 3, -5, 5, and then 8. So I can say that my P square in this case, when I multiply it, which is equal to what? P multiplying P, I'm getting matrix what? 3, -5, 5, and then what? 8. Okay, and then Q square, which is the same thing as what? Q multiplying what? Q. What was I getting? So let's see. That one to go to Shift 4. So B squared, that becomes the Q part. I was getting what? With my calculator, I was getting 17, 10, -20, -18. So once you get that, then you take the difference between the two, right? So we say that P squared minus Q squared should be equal to, so it is just actual subtraction. So corresponding entry will do. So this subtract from this, we are getting -14. And then this from this, we are getting -15. This from this, since the negative makes it a positive, you're getting 25. And then lastly, -8 subtracting from what? 8, we are getting what? 16. So once you know how to use a calculator, it makes the way so simple for you to actually go. If you don't want to use the calculator, you can go by multiplying it manually by applying your first or multiplying first column of the square matrix in that line before you get your answer in that line. Question 21. Given that y is equal to what? 2x cubed plus 2x squared plus 1 all to the power 5. You're asked to find dy over dx. So how do you go by this? So here too is the same thing as we did with the, I think, question 2 or so. If you can remember question 2. Can I take you there? This question number 2. So the same approach we're going to use. We bring the 4 down, we differentiate the terms in the bracket, and after we repeat the whole function and then subtract 1 from the power. That's what we're going to do. It's very simple. So question number 21, where is it? Yeah. So in this case, we will say that our dy over the x should be equal, so we'll bring the 5 down, okay, and we differentiate the terms in the bracket, that's term by term. So we have differential of 2x cubed will fetch me what? 6x squared. Differential of what? 2x squared will fetch me what? 4x. Differential of 1 is going to result to what? 0. So I don't take that into consideration. After that, I'll repeat the whole function, 2x what? Cube plus 2x squared plus 1. And I have my 5 subtract 1 from the 5. Okay, so at the end of the day, I can say that I can have 5 to bracket 6x squared plus 4x into bracket 2x what? Cube plus 2x squared plus 1 to the power of 4. Others might decide to multiply the 5 throughout this. It is not a crime. You still get the answer in that way. If it were to be an MCQ type, you might see this as possibly an option, or they might go further to multiply the whole of this 5 by what? 6x squared plus 4x, right? So let's take note of that. Question number 22. Given that matrix A is equal to what? 1, 2, 3, 4. Find the inverse of what? Matrix A. To find the inverse of a matrix is very simple. You first need to find the determinant of the matrix, and you find the inverse of that determinant. Okay. So if I want to find the inverse of 2, is the same thing as what? 2 to the inverse of 1, which is the same thing as what? 1 over 2. So if let's say I got my determinant to, let's say, 3. I want to find what? The inverse of 3. That becomes 3 to the power 1, and that should be what? 1 over 3. Okay, so once you find what the determinant of the matrix, you find the inverse of the determinant, and then you use that to multiply the interchange position of what? The downward what values, and then negation of what? The upward values. I will do that for you to understand. So first, we need to find the determinant of what this matrix. So we'll say that det A should be equal, so here 1 by 4, we are getting 4, and then 3 multiplying 2. So that becomes what? That becomes what? 1 by 4 minus 3 by what? 2. We are getting here to be 4, we are getting here to be 6, and we are getting what? Negative 2. So the inverse of negative 2 going to fetch us what? Negative 1 over what? 2, right? So by determinant, or by an inverse, we will say that therefore A inverse should be equal to 1 over the determinant. So the determinant here is what? Negative 2. Okay. And then multiply by the interchange position of what? 1 and 4. So if here is 1, the 4 will take that position, and then the 1 here come and take the 4th position here. So that becomes what? 4, 1, and then we negate 3, and then what? 2. So negation of 3, negation of 2. Okay, so at the end of the day, we say that here it becomes a scalar multiplication of this what? Matrix, of this new matrix. So negative 1 over 2 multiplying 4, we are getting what? Negative 2. Negative 1 over 2 multiplying what? Negative 2, we are getting what? Positive 1. Then here we are getting 3 over 2, and here we are getting what? Negative 2. Sorry, negative 1 over 2. And we get what? So the inverse of what? 1, 2, 3, 4 is actually what? Negative 2, 1, 3 over 2, negative 1 over 2. So let's take note of that. Question number 23. Find the values of k for which the matrix has no inverse. So if a matrix has no inverse, it means that the determinant of such matrix is what? 0. So assuming that when you find a matrix, when you find the determinant of this matrix and we're getting 0, meaning that the inverse of this matrix, when here is 0, everything here is also going to be 0. So there's no need. So if an inverse, if a matrix has no inverse, then the determinant is equal to what? 0. So we therefore need to find k by saying that find the determinant of this matrix. So that should be what? 2 multiplying what? K minus 8 multiplying what? 7. Okay. And that should be equal to what? 0. Since the matrix has no inverse, a determinant will also be equal to what? 0. So what will be k? So we have 2k to be equal to what? Negative 8, or 8 multiplying 7, we are getting what? 56. And since the negative, when it joins the 0, become positive what? 56. We divide both sides by 2, we get k to be equal to what? Is it 28 or 29? So when we divide k by 2, what are we getting? What are we getting? Are you going to get 28? Yeah, I think it's 28. Or 29. Let's see, I have my calculator here. 56 divided by 2. Yeah, 28, sure. So you get 28. So that is that. A fair marginal cost function for a product is 2Q plus 50, and its marginal revenue is what? 200 minus 4Q. And that the cost of production is, and that of the cost of production and sale of 10 units is what? 100. So here is actually an information for cost. The cost of production and sale of 10 units. So when production level is 10 units, the cost is what? 700 cedis. So we're going to use this at the cost function. So be guided. So you have to use this information to provide an answer to question 24, 25, and then 26. Please do also like the video, share it as well, so that others will get the benefit to join us and learn on this channel. So our first question is find the optimal level of production. So to find the optimal level of production, we say that our marginal cost should be equal to our marginal revenue. To find the optimal level of production, we say that our marginal cost should be equal to our marginal revenue. Or the difference between the revenue function and cost function can also be the way that we can find our optimal level of production. But always our marginal cost should be equal to our marginal revenue. That is the ultimate level of production. So we therefore say that our MC should be equal to our M what R. All right. So what is our MC was what 2Q plus what 50? Minus 4Q. So here, all I want to do is to what? All I want to do is to what? Make Q the subject. Make Q the subject. So we say that 2Q. We say that 2Q. So here is what? 100, and we have 200 here, and then the 50 will join the 200, making it to a negative. Okay, so you get 6Q. Get here to be what? 150. So what are we getting? So here, when I divide both sides by 6, I should be able to get what? 25. That is what I get at the end of the day. I had 25 in that line. 25. So therefore, my Q is what? 25. Then to question 25, you have to find a profit function. How do you find a profit function? Profit function should always be equal to the difference between what? The revenue function and the cost function. So revenue function of Q minus the cost function of what? Q. That will help us to find what's the profit function. Okay, so in doing that, we need to know our revenue function. We need to know our cost function because we are given marginal cost and the marginal revenue. So we must integrate the two so that we get them back. So let's work out for the integral of what? The cost and then the revenue. So my marginal cost will always be equal to that of what? My cost prime of what? Q, total cost. Okay, and if I want to integrate, in this case was given as what? 2Q. Okay, oh, what am I writing like this? 2Q plus what? 50. So I need just to integrate this. So when I integrate this, I'll get my total cost, and that should be equal. The integral of what? 2Q should be what? Should be 2 over 2Q square plus 50Q. Since this is an indefinite integral, introduce constant, say C. Okay, but remember we were given that the cost of production and sale of 10 units is what? 700. So we can use this information to actually. So now we actually know our level of output. Okay, that will fetch us the total cost function, right? So therefore, we say that if 10 units, if S got 10, then our total cost should be what? 700. So we say that 700. The reason why we do that is to find what? The constant value, or to find the C. So we have what? 700 to be equal to 2 can cancel the 2. So I can say that here becomes what? 10 square plus here becomes 15 to bracket 10 plus C. Okay. So here, what am I getting? Going to get what? 100. Here I'm getting what? 500. Here I'm getting C. And I'm getting here to be 700. When I add 100 plus 500, I'm getting what? 600. When I subtract that from 700, I'm getting what? 100. So therefore, my C is equal to what? 100. So therefore, my total cost function of Q is equal to what? Q square plus 50Q plus what? 100. Okay. All right. So once able to get that, that's fine. So let me have that one here. So I'll say that minus, I'll bring it here, minus Q square 50Q plus 100 as my cost function. Then let's get back to the revenue function. Let me have some space for it. So I'm going to clean this to have some space. So for that of the total revenue to you, we're going to do the same thing. We have our marginal revenue being the R prime of Q, and that was what? 200. That was 200 minus what? 4Q. Okay. So in this particular case, we just have to integrate this. So integral of what? R prime of Q should fetch us what? My revenue. And that should be equal to the integral of 200 should fetch more 200 Q. The integral of what? Negative 4 Q should fetch what? 4Q square over 2. And since that indefinite integral, we'll say that plus what? C as being a constant. Okay, so once you get a constant in that line, then we can say that here, since actually the number of units that was given was for the cost, and then they didn't provide us the revenue, we can't use the 10 units to actually, because when we say at the production level of 10 units, what is that revenue? We don't know. So we can also make such assumption. But the only way we can make assumption is that, because it's possible that a business cannot operate indefinitely in the foreseeable future. There might be a time where it might actually stop business. So that is always what possible. So that's why we will say that at the production level of 0, our total revenue should be equal to what? 0. So here we'll make an assumption by using that if production level is 0, then total revenue should be equal to what? 0. Right? So that's what we're going to do here in that particular case. So we'll have here to be 0, and that should be equal to what? 200, 0. Then here should be what? 200, 0 square plus c. Called 4 divided by 2 going to fetch us what? 2. So 0 square plus c. So I don't know, the c is equal to what? 0. Everything is 0. So therefore, our revenue function of q is also giving us what? 200q minus what? Or what is it? 200q minus what? 2 minus 2q square. So that becomes our revenue function. So in this case, we will say that our revenue function is what? 200q minus 2q square. Okay, so therefore our profit function then should be, so here we have negative, so here the negative will affect the whole of this, so here becomes negative q square, and we have negative what? Q here, so that's going to give us what? Negative 3q square. We also have 200q, you also have what? 50q, but here is negative, we're going to affect making negative. So when I subtract negative 50q from 200, I'm getting what? 150. So 150q. And here I'll come back to this negative q square, negative 2q. I'm getting what? Negative 3q square. And here, I think that's all for this. So we come back to the 100, negative 100. So at the end of the day, your profit function should be equal to 150q minus negative 3q square minus what? 100. So let's take note of that. That is that we're asked to find in that particular case. So let's take note. Question number 26. Find the profit or loss at the optimal level. So we asked to find the profit or loss at the optimal. So what was our optimal level? That was what? 25, right? So to find the optimal level at the profit or loss, we are going to use the profit what function to find that. Okay. So we just use this equation to, and we substitute 25 wherever we see q, so that we find our profit or loss for this optimal what level, which is 25 from the profit function. So in this case, we will say that when our p is equal to 25, then we can say that we have here to 115 to bracket 25 minus 3 to bracket 25 squared minus 100. So what are we getting? Here you should be able to get to what? 3750 minus here you should be able to get what? 1875. Here you should be able to get to what? 100. By a calculator, you should be able to get these values I'm getting. All right. So at the end of the day, when you add, subtract, and do all stuff, you should be able to get to what? 1775. 1775. So 1775 being the profit at the optimal level. So let's take note of that. Question number 27. Express the simultaneous equation x plus 2y which is equal to negative 1 and 3x minus y is equal to 11 in a matrix form. So how do you express this in a matrix form? It's very simple. So we have what? 1 and 2. We have what? 3 and then negative y. So the first one should be what? The x plus 2y should be, the coefficient of x here is 1. So we have 1 and the coefficient of y is what? 2. So 2 here. So this first equation and the x and y coefficient is going to be the first row. And when we come to the second equation, the 3 and the negative are going to be the second what row of this matrix. So you're going to get here to be 3 and you get here to be negative 1. Saying the coefficient of x is 3 and then saying the coefficient of what y is what? Negative 1. So once you would get this matrix, right, that is that. You have to express this simultaneously going to the matrix form. So you're going to get this, and you can say that even that should be actually be equal to what? that should actually be equal to, so once you get this, you can as well multiply this by what? Your x and y being the vector, and that should be equal to what? -1 and then what? 11. Can have something like this. So it actually was in this form that we're able to convert to what? A simultaneous equation. That we're getting what? X plus 2y and then 3x minus what? Y is equal to negative, is equal to 11 actually. So the matrix form is what? This. These are the matrix form in that line. So let's take note of that. Question number 28. So we're asked to use information to answer question 28 and 29. The total cost function in thousands of euros for manufacturing X manipulator per year is given. So we have the cost function we have. So this is a cost function, 375 plus 25x minus 0.25x squared. So the question here is, what is the cost of producing the 31st manipulator using the marginal cost function, right? So we say that, first of all, we need to find the marginal cost from the cost function. So marginal cost, which is equal to the cost time of x, should be equal to, so differential of what? 375 should result to 0. Differential of 25x should result to what? 25. And differential of what? Negative 0.25x squared should result to, so here the 2 multiplied by 25, you are getting what? 0.5x. So you're going to get this as being your marginal cost, but we are talking about 31st. So for us to know the cost of only one manipulator at the 31st position, we will say that our cost of x plus 1 should always be equal to what? The 31st manipulator. So this becomes the additional cost of the whole what? Output that we produce as x. In this case, it was between the range of 0 less or equal to s less or equal to 50. Okay, so in this particular case, we'll solve for x and we use that to find the marginal cost at that level. So what are we getting? We're going to say that here we'll have what? X plus 1 to be equal to what? 31. So therefore x should be equal to 31 minus 1, and we are getting what? 30. So therefore, we have to find the marginal cost at the manipulator, find the cost of producing 31st manipulator using the marginal cost. It should be at the production level of what? 30. So at the production level of 30, we can find the marginal cost of what? 31st manipulator. And here it should be equal to 25. So whenever we see s, we'll substitute what? 30 there. So that should be 0.1530. Okay. So what are we getting? We have here to 25. We have here to be 15. So we are getting what? 10. But remember, we're told that the total cost function is in thousands of euros. So I don't know, they will multiply by 1,000. So that should tell you that here our marginal cost of producing one manipulator at the 31st level is what? 10,000. 10,000 what? Euros. 10,000 euros. So let's take note of that. Okay, question number 29. What is the exact cost of producing 31st manipulator using the total cost function? So you're talking about the exact cost of producing the 31st manipulator. So for us to know that too, we'll say that the exact cost should be the cost of 31 manipulators. Compare that to the cost of 30 manipulators. How we can see that difference? Because when you subtract 30 from 31, we get what? Just 1. So we want to know the exact cost of just one manipulator. How much does it cost? Okay, so this is what you're going to do. You substitute 31 in the cost function, which is what? This. Okay, and at the end they also come back and substitute 30 in this same cost function. Then after that, whatever you get for the two, you take the difference between the two and you are good to what? Go. Okay, so let's take note of that. So here, this what I always do. You pick your calculator. Okay, let's go back to our normal mode. Let's see. What is my mode? Yeah. So normal mode, I'll get this function on my calculator. 375 plus what? 25x alpha x minus 0.25 alpha x squared. Okay, so once I get this on my calculator, you just have to press solve, identify solve on your calculator. So when you press solve, you get a question mark, or you get s equal to get s question mark, s equal to question mark. Depends on the calculator. You get any of these things I'm saying. And I know they once you get s equal to what? question mark, whatever you want to solve for 31, so you press 31. So once you press 31, you press equal to sign, you're going to get your final answer being what? Here in, oh come on, what is this? In a decimal form, you're going to get what? 901.715. But remember, we are dealing with what? Thousands of euros. So I don't know, you multiply by what? 1,000, right? So when I substitute what? 31 into this function, I'm getting what? 901.75. So that becomes the first part of this. So here at the cost, I'm getting what? 901.75. And I also do same. I also press solve. I don't change anything. I'll press solve and then solve for 30. And I press equal to sign. That one I'm getting what? I was getting what? 900 here. So minus what? 900. Minus 900. So 900 there. All right. So once you're able to get it, take the difference between the two. What are we getting? So when I have 909.75 minus 900, I'm getting what? 9.75. I'm getting 9.75. So here becomes what? 9.75. But remember, you are dealing with thousands of, so I don't know, you multiply by what? 1,000. Okay. So when you multiply this by 1,000, we are getting what? 9,750 what? Euros. 9,000. So 9,750 what? Euros in that line. And this becomes the exact cost of producing just one manipulator at 31st level. So if we were to be, let's say, at 28th level, that means that for us to know the exact cost of 28 level, that should be what? That of what? 29, compare that to what? 28. The cost of 29 and the cost of 20, the difference is going to fetch us what? Just one. Hope we get that. Yeah, so that's how it actually should be in that line. So let's take note of that. But if we were to be at marginal, right, that should be the cost of our normal production plus one, and that should be equal to that particular level, say 25 or 25th or any other position that they're going to give to us. Just use that and you get your value of S and you substitute into the marginal cost function. So let's take note of that. So that becomes how we actually deal with these kind of questions. Then question number 30. We are asked to use the information above to solve question 30 and 31. So you're asked to evaluate A into bracket B minus what? C. So here we have A multiplying B minus what? C. So first of all, this is what we need to do. Okay. Matrix A is what? 2, 6, 4, 8. Okay. So this is actually multiplying matrix B, which is what? 3, 5, -7, 9. Okay. Compare that to what? C, which is what? -5, -1, 3, and then 2. Or in bracket, right? So we deal with the bracket first, that I will multiply by the external what? Vector. So what are we getting? All that we need to do here is to deal with the corresponding entries, right? So subtract -5 from what? 3, and that line to be exhaust the list. So we're going to have here to be what? 2, 6, 4, 8. So what are we getting with our big matrix bracket? So here, let's deal with this. So -5 taken from +3. Remember, here is negative, here so negative, so making it positive. So you get what? 8. So 3 plus 5, you get what? 8. So once you're able to get that, then you move on to the next. So you come back to that of what? The -1 subtracted from a -5. So here is negative, negative, positive, right? So you're going to get what? -4. Okay. And then the next is that you also deal with what? The other entries. So let's see the other entries. So here too, you subtract 3 from what? 7. So it becomes -7, -3. We are getting what? -10. And then here 2 from 9, we are getting what? 7. So once you're able to get 7, then now we can multiply with the 2 at what? A go. So here, bring your calculator. Let's go to matrix on a calculator. Let's see how far we can go. Then put this down a bit so that we can use the calculator. So now I'm going to deal with what these values. So I'll go to my mode, go to matrix, go to mode, I'll go to identify matrix, and then I'll get my matrix A. So the first is 2, and then the second is 6, and then third is 4, and then last one is 8. Okay, so that becomes matrix A. So I'm done. Now press AC, and I'll go to shift, I'll go to 4, and I need to identify my matrix what B. So that one too, the first entry is 8, the second is -4, the third is -10, the fourth is what 7. So once I'm done, that is fine. I'll press what AC. So since I'm multiplying, I'll press shift, press 4, bring in my matrix A. Okay, multiplying what, press shift, press 4, and I bring in my matrix what B. So when I multiply, I should be able to get what -44 34, -48 40. So the calculator will help to solve it very simple for you. So at the end of the day, this is what we are getting. When I multiply, I should be able to get what -44. Let's see, -44 34, and then -48 40, -48 40. You should be able to know how to use a calculator better so that you can ease your chance of what solving enough questions at the examination room, should in case you have any future examination in relation to this. So this is how I use the calculator to actually to deal with it. So since we actually so okay, that's fine. So we also asked to what evaluate what a square minus b. So a square, I think you remember we solved something similar to this where we say p square minus q square. So the same thing here, that is a multiplying what a. That is a multiplying what a. Then b squared to those are, that is what b multiplying what b. B multiplying b multiplying b. So we just have to bring our calculator again. So we go to our matrices. So now we need to change the values. So now we know that our a, oh come on, we know that what are the values for a. We know that a is what 2, and then we have 6, we have 4. Oh, I think I have them already. We have what 8. Okay, that's fine. So I'll press AC. I'll go to shift, then 4, then go for my matrix B. Okay, this one is going to be a bit changing. So here, because of the multiplication, so I have here to be 3, -5, okay, -7, and then lastly 9. Okay, so once you're able to get this, you also press AC. So since we're asked to find what a square, this is what you're going to do. You press your shift, you identify 4, you go to what matrix A, you squared it. What are we getting? So when you square what a, that is the product of this, should be able to get what this. So you're going to get what 28, 60, 40, 88. Then you do same with the B2. Shift 4, you identify your matrix B, you squared it. That one you're going to get what 44, 60, just negative, then -84, 116. So once you're able to get these values down, then what are we getting? You just have to take the difference between the two. So when I subtract a square and then b square, so that's what you can do here. Now you can bring in all the matrix. So a square minus b square, and you are getting your final answer to be what -16. So when I do the subtraction, therefore my a square minus my b square, I should be able to get what negative what 16, 120, okay, 124, 124, -28. So calculator will always help you to do the work or solve enough question when it comes to issues about this. Or you can go by multiplying using normal multiplication, for which you know already, and there are videos on that too as well. Question 32. One product firm estimate that its daily total cost function in suitable unit costs this. So you have s cubed minus 6s squared in that line. Revenue function is what? 28x. So we have to find the value of s that maximizes. So at the maximization of profit, we say that our marginal revenue should be equal to our marginal cost. So what is the marginal cost here? So our marginal cost should be equal to the differential of cost function. Okay, so what are we getting? We are getting what? So differential of what? S cubed, we are getting what? 3s squared. Differential of what? Negative 6s squared, we are getting what? 12x. Differential of 13x, we are getting what? 13. And differential of 15, we are getting 0. So that's our marginal cost. That's the differential. And then our revenue function, being our marginal revenue, should be the first differential. So differential of 28s should fetch us what? 28. So we are saying that at the level where we want to maximize daily profit or want to maximize profit, our marginal revenue should be equal to our marginal cost. So at the end of the day, we will say that MC should be equal to MR. So what are we getting? We have what? 3s squared minus 12x plus 13, and that should be equal to what? 28. And that should be equal to 28. Okay, so at the end of the day, we'll group them in a quadratic form. So what are we getting? We have what? 3s squared, okay, minus 12x. Remember, the 20 when you join the 13 becomes negative, right? So negative what? So when you subtract 13, 20 from 13, you are getting negative 15. I hope that is correct. You can comment that if that's correct in that line. So once you're able to get this, then it becomes a quadratic, right? So we'll have 3s squared minus 12x minus 15 to be equal to 0. Okay, so you bring in your calculator once again. So you go to mode, you go to 5. So let me clear this off first. So I'll go to mode, you go to on the calculator, you go to mode, you go to 5, but mine is different. I just have to go to mode and I'll identify what? AS squared plus BS plus C. So once I identify that, I know that the coefficient of x squared is 3, so I have the 3 here. That of x is what? Negative 12. So put it there. And that of what? The constant is negative 15. Get it there. So therefore, my x1 should be equal to negative 1. So that means when I reverse it, it becomes what? X plus 1 into bracket. Then here too, I have x equal to what? 5. So when I reverse it, it becomes what? X minus 5. And that should be equal to 0. So therefore, we have x to be equal to negative 1, positive what? 5. But since we are asked to find the value of x, just one value, and since we know that the coefficient of x here is actually positive, we will say that since x is greater than 0, therefore, at the value or at the level that will maximize daily profit should be equal to what? X should be equal to what? 5. And that should be the point that we should know at the end of the day. So let's take note of that. Question number 33. A manufacturing company finds that the daily cost of producing S item of a product is given by, so this, if each item is sold for 350 Ghana cedis, that's Ghana shilling, find the minimum number that must be produced and sold daily to ensure no loss. So at the minimum level or number that will ensure no loss means that we are at a point where we neither make a profit or a loss, and we are bringing in the issue about what? Break even. So at the point of break even, our total revenue should be equal to our total cost. And we know the cost to be what? 210x plus 7,000. But we know that the selling price of each item is what? 350. And let's say our production level is what? X. That should mean that our total revenue function should be equal to what? The selling price per one, which is the P, multiplying what? Our daily output that we produce as X. So what is our selling price per one? That's 350 multiplying X. So this becomes our total revenue function, our total cost, which is what? 210X plus what? 7. So therefore, we say that total revenue of what? 350X should be equal to total cost of what? 210X plus what? 7,000. So once you're able to get this, you have to make what x the subject. So what are we getting? When I subtract this from this, I'm getting what 140x, and that should be equal to what 7,000. So I know that we said that my x should be equal to 7,000 divided by what 140. And what am I getting? With my case, I arrive at what x to be equal to what 50. So to ensure no loss means that we are neither making a profit or a loss. So at that point, our total cost should be equal to our total revenue. Then question 34, if the selling price is increased by what 35 Ghana shilling per piece, what will be the break-even? So you see the issue you're talking about, break-even point. So here there's a change in the selling price, and that's increased by what 35. So we get our new selling price. Our new selling price to be equal to what? The old plus what the increase, which is what 385. So once you are getting 385, therefore we can also find our new total revenue, which should be equal to what? The new selling price of 385 multiplying the output of X. Okay. So what will be the break-even? So at the break-even point two, our total cost should be equal to our total what revenue. So in this case, our new total revenue should be equal to our total what cost. All right. So we say that 385x should be equal to 210x plus what 7,000. So here, when we take the difference between the two, it should be, so the 210 will join this, making it negative. So when I subtract, I'm going to get what 175s, and that should be equal to what 7,000. So divide both sides by 175, divide both sides by 175. Therefore, we are getting x to be equal to 40. You can confirm that with your calculator and let's see if that's true. So x is going to give us what 40 in that line. So that is that. If a is equal to if a is equal to 4, negative 2, 3x5, find the value of s if the determinant of a is 32. So the same thing. So here, multiply 4 by 5, compare that to 3x minus 2. All right, the product of that, and you create 32. So we're going to have here to be what? 4 multiplying 5 minus 3x multiplying negative 2. Okay, and that should be equal to what? 32. So you have here to be 20. You have here to be what? Negative 6x, and that should be equal to 32. Okay, so negative, negative, making what? Positive. So we'll have what? 20 plus 6x, and that should be equal to 32. So therefore, 6x should be equal to 32 minus 20. Okay, so we have 6x to be equal to what? 12. So we divide both sides by 6, and we are getting x to be equal to what? 2. All right, so the value of x when determinant a is equal to 2 is what? 2. So just substitute there and get the whole of this entry to be what? 6. So 36, if y is equal to x into bracket x cubed minus x plus 1, the value of, so we are talking about what? This a definite what? Integral. So you see the limit here, the upper limit and lower limit. So what I want to do here is to what? Simplify this to its simplest one before you bring your calculator to solve that. Very simple. So this is what you're going to do. You said that y should be, so you just have to multiply this by this. So x multiplying x cubed, we are getting, so here is 1. Law of indices, when the bases are the same, you add the power. So we make it what? X to the power 4. Okay, and multiply x by negative x, we are getting what? Negative x squared. Multiply x by 1, we are getting plus x. So once you're able to get these values or this function, you bring your calculator, because this is a definite integral where we have our limit. You can use calculator to solve for it, and it makes it very simple. All right, so we identify what your integral function, which is this. Okay, on the calculator. Okay, so you see at the top here, that should be the upper limit. So the upper limit is 1, and then the lower limit is what? Negative 1. And then here it should be the place where you substitute your function. So we have what? Alpha x to the power what? 4. Okay. Then we have minus alpha x to the power what? 2. Then we have plus x. So once you're able to key this on the calculator, just press equal to sign. Okay, for my case, just give your answer straight away. So you get what? Negative what? 4 out of 15. But for yours, I think you need to press equal to sign and you get your answer in that line. So that's how it's going. So here, when I put on the calculator, I'll get my final answer to be equal to what? So that means that the integral of what? 1 negative 1 of what? X to the power 4 x squared plus x should give me what? Should give me what? Negative 4 over what? 15. If you want to solve this manually too, you just follow the steps. You integrate, then you bring in the upper limit and the lower limit, and then you take the difference between the two, you get your answer in that line. Okay, I see some question here. Let's see if we can attend that. I think that is what I'm doing. So at certain points where we can use calculator, I will let you know, or I always let you know in that line as I just did here. So churches, that's fine. So question number 37, we are asked to find the determinant of matrix P. So here we can use calculator to do that. So let's see how we use the calculator to find the determinant of a 3 by 3 matrix. So here, this is what you want to do. You go to your matrix as usual. So you go to mode, you select your matrix. So once you select your matrix, you want to key in the matrix 3 by 3 matrix, right? So for my case, I need to go by what? Matrix D. That's a 3 by 3 one. But in this case, I go to shift 4. I need to go to edit part of this of my case. Okay, and then for yours, once you get to the matrix mode, you see the scale 2 by 2, 3 by 3, and then you select one, and then you just key in it. You press AC and then follow what I was teaching, shift plus 4, and then you can easily get whatever you want to solve for. All right. So when you press shift plus 4, I'm going to give you some list that you see there. You see some of them, determinant and those kind of stuff. You just have to select it and then you get it. So here the first entry is for 2. So I'll press 2. Next is 1. The next is 1. Then second row 2, 3, 5. Then the third row we have 2. We have 1. We have 1 and we have 4. Okay. So once you're able to get this, I hope you can see my calculator. Once you're able to get this, so we have 2, 1, 1, we have 2, 3, 5, and we have 2, 1, 4. So once you're able to get this, you just press AC and you are done. So with my case, I'll press shift, I'll press 4, and I'll go to my math here. Now select my determinant. So once the determinant appears on my screen, I'll go to shift again, I'll go to 4, and then I'll come back to the name. So I'll select matrix what? D. And then I'm getting my determinant to be what? 12. Very simple. 12. Very simple. So therefore, that P is equal to what? 12. Let's see if that is true. If you want to confirm that we're using your upward and downward arrows, that's also very simple. So you have 2, 2, 2, 1, 3, 1, 1, 5, 4. So you just have to repeat what the first two words columns. So you have 2, 2, 2. We have 1, 3, 1. Okay, so let's deal with our downward arrows. So we have this. So first we have this, that, and that. So upward, that, this, and then that. Okay. So when I multiply 2 by 3 by 4, I'm getting what? 24. I hope that is true. I'm getting 24. Because here it's 12, 24, sure. So here to get 10, and here I'll get what? 2. Then the upward, I'll get here to be 6. I'll get here to be 10, and I'll get here to be, let's see, 4 by 2, 8. So at the end of the day, downward, upward. So 10 plus what? 10 plus 24, I'm getting what? 34 plus 2, I'm getting what? 36. So I have 36, and then here, I'll compare that to what? Here, 18 plus 6, I'm getting 24. So 36 minus 24, what are we getting? What are we getting? So 36 minus 24. we are getting 12, right? So we get 12 as we get with our calculator. So we get 12. So anyway you want to go, you are good to go. So that is the determinant. I think we have solved some of these with the upward and downward arrow. So that's why I just want to focus more on that. And likewise, you can also solve this even for me. You have to find it if the determinant of this is equal to 5x, find the value of x. So here you just find the determinant of what this matrix m and equal to what 5x, and then you solve for the value of x. Very simple. So we say that x multiplying x, so x multiplying x, compare that to 6 multiplying -1, and that should be equal to what 5x. Okay, so we are getting what x square. We are getting x square. We are getting here to be what -6, -1. You are getting +6, and that should be equal to 5x. So here, once you see this, you must group them in the form of ax squared plus bx plus c. So we have x squared minus 5x plus 6, and that should be equal to 0. So once you're able to get this, you bring in your calculator once again. So calculator, you go to what? You go to your normal mode. You select ax squared plus. So you also go to mode, you go to 5, and you select 3 for ax squared plus bx plus c. So here, the coefficient of x is 1, that of x is -5, and that of what c is what 6. So once I will get this, I'll press equal to sign. I get my x to be equal to what? So here is +2, so that's going to be -2 in bracket, and then 3. So I have what x -3 in bracket, and all should be equal to what 0. So therefore, we'll say that x should be equal to 2, comma, and what 3. So that is our value of what x. That is our value of x in that line. So let's take note of that. Let's take note of that. Now let's move on to question number 39. Question number 39. Question number 39. 39 says a company manufactures and sells S transistors radio per week. So very important, per week. If the weekly cost and price okay, I think someone is saying that about a definite integral, the calculated or answer is always what in decimal. What can we do to get that? It's not always that it should be in decimal. It depends on the number that you get, right? If it's a whole number, you can get a decimal. So if you are getting a decimal, this is what you need to do. This is what you need to. You see on the calculator, you have something called XD. So if you have any decimal, just press XD, and it will bring in a fraction for you. Okay, just press XD on your calculator and you get that. I hope that satisfies your question. Okay, question number 39. Let's see. So a company manufactures and sells S transistors. Please let's share the video and like it as well, so that others will get the benefit to join in that case. A company manufactures and sells S transistors radio per week. So this is a weekly information. If the weekly cost and price demand equation is equal to this and that, and it goes on to tell us that there are what 4 weeks in each month, we are asked to use this information to answer question 39 and what 40. So how do you go by this? How do you go by this? So what is the maximum revenue for 2 weeks? Remember, the information given here was what a weekly what information, 1 week information. So you want 2 weeks, meaning that whatever you get as your maximum revenue for a week, you multiply by what 2. So let's see how we get the maximum. Well, by maximum, we need to find our revenue what function, right? So what will be our revenue function? So total revenue function should always be equal to our total sales should always be equal to our price per item multiplying with the output that we produce as organization, which is what x. Okay, so what was our price function? It was what 10 minus x over what 1000, or multiplying what our output as what x. So therefore, our total revenue function should be equal to 10 multiply x, we are getting what 10x, and then x multiply x over 1000, you are getting what x squared over what 1000. Okay. We're getting x squared over what? 1,000. So once you get it, that becomes our total revenue function. But we are asked to find the maximum revenue for the 2 weeks. So to find the maximum revenue, you need to differentiate the revenue function. So that's what we're going to do. We'll say that TR prime of x should be equal to, so the differential of 10x should result to 10. Differential of what? X squared over 1,000 will result to what? Will result to x over 500. How is that possible? I can write this as what? 1 over what? 1,000 x squared. Okay, so the 2 will multiply with the coefficient of 1, which is 1 over 1,000. So when the 2 multiplies, I'm getting what? 2 over what? 1,000, and then have here to be x. So 2 goes here, 1, it goes to 1,000 what? 500. That's why I was getting what? X over what? 500. So this becomes, so once able to get this, we say that at the first differential, our at the first differential, the derivative should always be equal to what? 0. So this is what we're going to do. So we say that since tr prime of x is equal to 0, then we can find the value of what? X. So this is what we're going to do. We say that 0 should be equal to 10 minus what? X over 500. So at the point where we at rest, or the curve is at rest, that's at first differential, it should be always be equal to what? 0. So once it's equal to 0, therefore we can find our value of what? X, right? So this is what we do. We'll bring in the x, so it becomes what? X over 500, where the 0 is, and that should be equal to 10. So cross multiplication, 500 multiplying 10, x multiplying 1, right? Because here is negative. When it joins, it becomes a positive in that case. So the 10 also remains there in that line. So therefore, we say that our x should be equal to what? 10 multiplying 500, and we are getting what? 5,000. So that is 5,000 units of what? Output. This is for a week. So for us to know our maximum revenue, once we get the value of x, our maximum revenue will come from the total revenue function, where we substitute what? The value of x, which is what? 5,000. Hope we get that. So in this particular case, this is what we're going to do. We will say that our total revenue at the 5,000 output should be equal to what? 10 into bracket 5,000, okay, minus 5,000 all squared divided by all squared divided by all squared divided by 1,000. Once you get the value of x after differential, substitute back to the original function that we gotten. So in this case, what are we getting? In this case, what are we getting? What are we getting? So when I multiply this, I'm going to get what? 50,000. Okay. And then when I also apply this, let's see with our calculator. Or is it? Let's go to our normal mode. So 5,000 squared divided by, all right? So at the end of the day, we're going to get 25,000. So our total revenue is 25,000. But remember, this 25,000 is for just 1 week, because we're given a weekly information. Okay, so once you're able to get a 1 week what maximum revenue, therefore will be 2 weeks, you multiply by what? 2. So therefore our total revenue for 2 weeks should be equal to what? 2 multiplying 25,000, and we are getting what? 50,000. If we were to be say a month, meaning that for months we have 4 weeks, so we should have multiplied by what? 4, and you get what? Whatever you want to get at the end of the day, right? So let's be guided. The next is, what is the maximum monthly profit? What is the maximum monthly profit? How do you find the maximum monthly profit? So how do you find the profit function? That's what you're going to do. How do you find the profit function? That's what we're going to do. So profit function is derived by what? The difference between what? The revenue function and then the cost what? Function. So once you find the difference so that you get the profit function, then for you to find the maximum profit, you have to differentiate the profit function so that you find the value of the output and then you come back and substitute into the profit function and you get that maximum in that line. So that's what we're going to do. So let's take note. I'm coming. So here, all I want to do is to say that we just have to find our profit function. So we already know our revenue function. So our profit function of x should be equal to our revenue function of what? 10x minus s squared over 1,000. Compare that to the cost function, which was what? 500, 5,000 rather, plus what? 2x. Okay, so what are we getting? In this particular case, what should we be able to get at the end of the day? So here, we just have to do the comparison right and get it. So we can subtract 2s from 10 because here the whole of it is going to be negative, right? So negative 2s from 10. So that's going to give us what? 8x. Okay, and then we get what? Negative 8s squared over 1,000 minus what? 5,000. So this becomes our profit function at the end of the day. But we have to find the maximum what? Profit. That's a monthly maximum profit. We deal with. So in this case, for me to find my maximum profit, I'll just have to differentiate the profit function. So I will say that p prime of x should be equal to, so differential of what? 8x should fetch me 8. Differential of what? Negative s squared over 1,000 will fetch me what? X over what? 500, right? Because I can write it as 1 over 1,000 and then multiply 2 by 1 over 1,000 and subtract 1 from the 2. And that's going to fetch me x over 500. Then differential of what? 5,000 is 0. So at the end of the day, we know that at first differential, it should always be equal to what? 0. So at p of s is equal to 0. Therefore, we can say that 8 minus x divided by 500 should be equal to 0. So we have our 8 here and we have x over 500 cross multiplication, right? So 500 multiplying 8, x multiplying 1. So you're going to get x multiplying what? 8 by 4, what are we getting? We are getting 40, right? So 8 by 4, sorry, 8 by 5, we are getting 4. So that's going to be 4,000. So you're going to get what? 4,000. So this 4,000 becomes what? The value of x. So for us to know the maximum what? Profit. By a maximum function, always the coefficient of what? X squared is always what? Negative. That's why we were saying here to be negative. Negative what? X squared. So x squared is what? Negative. So if you want to identify a maximum function, the coefficient of x squared should be what? Negative. Okay, that's why the question asks us to find the maximum what? Monthly profit function. So the guide, if we're to a minimum, then you see that the coefficient of x squared is positive. Let's take note. Okay, so once you're able to get the x, then we'll come back and substitute the 4,000 into this original function as we did for the revenue function. So once we get the x, we substitute into the original function. So that's what we are doing here. So therefore, we'll say that our maximum profit function of 4,000 should be equal to, so we have what? 8 over 4,000 minus 4,000 squared over 1,000 minus what? 5,000. So even with this, you can get this on your calculator as a function, okay? All I want to do is say you have what? 8 alpha x. Come on. Alpha x, where is my x? I can't see my x. How is it? Okay, alpha x minus, we have what? Alpha x squared over 1,000 minus 5,000. So once you get this on your calculator, just have to press solve, and you solve for what? 4,000. And you press, you should be able to get what? 11,000. So with that, you're going to get what? A maximum profit from the profit function to what? 11,000. Okay. So be guided about that. Straight away, we get 11,000 in that line. But here, to achieve every part, you need to get the answer for this, and have this two. After that, you simplify it so that you get your 11,000 in that. So once you get 11,000, that becomes what? The weekly maximum profit. But the question asks us to find what? A monthly profit, since we were given a weekly information. This is why we need to take notes, because if we don't take that into consideration, you might get it wrong. So once you find the weekly what? Maximum profit, then what will be a monthly maximum? So how many weeks do you have in a month? 4. So therefore, our monthly maximum profit should be what? 4 times the profit what? Function. And that should be what? 4 multiplying what? 11,000. And we should be able to get what? 44,000, right? And should be able to get 44,000. Okay, so this becomes a maximum monthly profit. Then what is the weekly profit function? So what was the weekly profit function? That is this, right? That we have done. So here it is what? Just have to write it. 8x minus x squared over what? 1,000 minus what? 5,000. That is all. Then question 42. What is the price that will realize the maximum profit? What is the price that will realize the maximum profit? So what is the price that will realize the maximum profit? So the maximum profit, the price that will realize the maximum profit, meaning that we need to find that of what, or we need to take into account the value of x when we're finding what at the maximization of profit using the profit function. So once you know that unit or the level of which was, or in the case was 4,000, okay, we use that and substitute into the price function so that we get to know the price for the profit what level of production. So that is the meaning behind what is the price that will realize the maximum what profit. So we'll take into account the unit of output at the profit level. When we find the first derivative, substitute that into the price function, then we get the price for that. So therefore, we say that the price function for which we know it was what 10 minus what and x over 1,000 should be, so at the price level of what with the profit level of output to be 4,000, you should be able to get 10 minus what 4,000 divided by what 1,000. Okay, so 3 zeros comes to 3 zeros. So we are left with what 10 minus 4, and we are getting what 6. So the selling price per every unit at the profit level is what 6 Ghana what shilling, right? So let's take note of that. Question number 43. Question number 4, we are asked to find the determinant of this matrix. So here too, you go by using your upward and downward arrows, and we are good to actually go in that line. By seeing some of the information is missing, I want to track it up and let's see. So here, question 43, we're having, so the first row is actually 1, 1, 2, and then here is what, 3. Okay. All right. So determinant, as usual, can use a calculator to do that. Okay. So calculator work, and then you're good to go. You go to matrix. So you go to your mode, you go to your matrix. So with my go to my edit, and then since a 3 by 3, I'll identify my 3 by 3. I'll use the D. So I need to get this off. Okay, so let me go back shift 4. So go by D. So the first entry is 1, 1, and then press equal to sign. Let me bring it here. So you have 1, press equal to sign. The second one is 2. The third one is 3. The second row, 0, -4, then 1. Then we have 0, we have 3, we have 4. So once you are done, just press AC, you press shift, you press 4, and then you go to your math, or with your case, you need to identify determinant. So that's that. So I'll press that, and then I'll press shift, I'll press 4 again, and I'll bring in my matrix, 3 by 3 matrix, which is what? I selected D, so I'll just have to select D, and I'm getting what? Negative what? 19. Getting negative 19. Did I actually key in my values to all? Okay, let's see. Let me check the values. So let's go. So you're having 1, 2, 3, 0, -4, 1, 0, 3. Oh, the last one here was -1. I think so. -1 or 4. So when you do that, you should be able to get a different one. Okay, so I see. So go to name D. So you should be able to get 1 actually. Because here was what? -1. I made it as 4. So I was getting a different or determinant. So let's take it. So you get what? 1 in that line. So this one, so you can use your downward arrows approach to do it, and you are good to go. So solve it on your own, as we have dealt with using calculator. Then question 44, find the values of k for which the matrix A has no. So we said that if a matrix has no inverse, then it means that the determinant of such matrix is also what? Equal to 0. Okay, so we say that k plus 1, or multiplying what? K. So this multiply this, compare that to 1 multiplying 6 should be equal to what? 0. So we have k squared, we have k, we have -6 to be equal to 0. So now we are getting a quadratic, as you can see here. Okay, so just bring in your calculator, go to mode, go to 5, and select 3. So let me go to my, so you also go to mode, you go to 5, select 3. So here I just move straight, just bring in there. So I know that the coefficient of x square is what? 1. So my 1 is here. Then x is what? K, which is 1, 2. And then constant is -6. So 6 there. So when you do that, you should be able to get your final answer. X1 to be -3, and x2 be equal to what? 2. So we'll say that we'll have what? K plus 3, K minus 2. I think that is true. -3 minus 2. Okay. So that should be equal to 0. So therefore, k is equal to -3, +4, 2. So the values of k for which the matrix has no inverse is -3, 2. Because at that point, determinant is also equal to what? 0. Question 45. Given that a is equal to 4, and then 4, 1, 2, 3, and then b is equal to 1, -2, -1, 4. We have to find what? 2a plus what? 3b. So here is also a scalar multiplication, right? So straight away, we can say that 2 will multiply the entries in the matrix A. So 2 multiplying 4, we are getting A. 2 multiplying 1, we are getting what? 2. 2 multiplying 2, we are getting 4. 2 multiplying 3, we are getting what? 6. Okay, then we say plus. Then 3 multiplying what? 1, we are getting 3. 3 multiplying negative 2, we are getting negative 6. 3 multiplying negative, we are getting negative 3. 3 multiplying 4, we are getting 12. So once you're able to get this, that is a 2a plus 3b approach. So just deal with what adding corresponding what entry. So 8 plus 3, you are getting 11. Negative 6 plus you are getting what? Negative 4. 4 plus negative 3, you are getting what? 1. And then 6 plus 12, you are getting what? 18. And you are done. Done. So question 46. Question 46. Given that 1, 0, 2x, and then we have 3, 2, 0, 1 is equal to, you have to find the value of what? X, right? So this is actually a multiplication, right? So here we are interested in the value of x. So we're going to deal with the value of x approaches, right? So we just have to bring in this, the second row of the first matrix here to multiply the entries in the second matrix. So this 2 multiplying 3, we are getting what? 6, right? So 2 by 3, we are getting 6. Then we say that plus x multiplying 0, we are getting 0. Okay, after that, we also bring in 2 multiplying 2, you are getting 4. X multiplying 1, we are getting what? X. Okay, so here is a question mark, but we are not interested in that piece. So we just provide that, and that should be equal to 3, 2, 6, 3. So therefore, we just have to do the corresponding. So we have 4 plus x, and that should be equal to what? 3 here. Okay, so we have 4 plus x should be equal to 3. So therefore, x should be equal to 3 minus 4. And we are getting x to be equal to what? Negative what? 1. Negative 1. So therefore, x is equal to negative 1. So don't waste time to solve for all these values. Just identify where the problem is and then deal with it in that line. You are good to go. Question 47. If A is equal to this and B is equal to, let's say, question 47, we have to find what? It didn't appear well. Typing mistake there. Let's check. I'm check from here. Question 47. Question 47. Question 47. So we're having 6, 9, negative 4, 6, and we're having what? And we're also having the B to be. Oh, I'm not saying. Okay, let me check before we got it done. Okay, since the B part is 1, 2, negative 1, 0. So here it is 1, 2, negative 1, 0. So we're asked to find what? A square multiplying what? B. That's the requirement. A square multiplying what? B. So we have to find this A square dot B. And we have seen majority of this in our question solving. So what I want to do is to go to matrix again with our calculator. So let me go to our normal mode. So go to my matrix. And then this is a 2 by 2. So I'll select A. Okay, so bring in the 4, go to my edit and then edit A. So first entry 6. 6. And then the second one is what? 9. The third is negative 4. Then negative 6. So that is for the A part. Okay, so once I'm done, I cleared it off. Now I'll go to shift, press 4. I'll go to matrix B. which in this case has been given as what? So 1, 2, -1, 0. Okay, so I'll just press AC. So for me to know my A square, press Shift, go to 4, then I'll select my A. So when it comes, I'll just have to square it. When I square it, I'm getting what? 0, 0. So meaning that A square from our calculation solving here is 0, 0, 0. So this is now what? Matrix. So 0, 0. What will be our B2? So B2, go to Shift, you go to 4. You have to select B. And B in this case was what? As we were given was what? 1, 2, -1, 0. So when you have a matrix that has 0 multiplying this, everything will result towards 0. So 0, 0, 0, 0. You can try. So if you like, let's see, Shift 4. So you're gonna go to 4, you square it, multiplying, Shift 4, you go to B. You're getting 0, 0 as you can see on the calculator, right? So that is that simple. So it's very important for us to know how to use calculator to solve. It's gonna save us a lot in examination condition. Solve for x in the matrix. So we have what? X plus -3, -2, 0, 6 is equal to 6, -1, -2, 0. Okay, so here we have x plus this matrix. So all I want to just to make as a subject. So we have x to be equal to 6, -1, -2, 0. Okay. And then, so here is positive, it becomes negative here. So minus -3, -2, 0, 6. Okay. So you subtract. So -6, +6, minus, so we are getting what? 9, right? So you're getting 9 here. Okay. And then that of -1, subtract -2 from -1, we are getting what? +1. Then here 0 from negative, we are getting -2. And then here 6 from 0, we are getting -6 in that line. So let's take note of that. So you get x to be equal to what? 9, 1, -2, negative. So we just have to make x the subject and then subtract the two matrices in that line. 49. A is equal to negative. A inverse of 1 is equal to 1/7. Find A. So you have to find what? The original what? Matrix where it wasn't in the inverse word form. So here, if you want to identify, it's actually very simple. We say that for us to find an inverse of the matrix, it should always be, so let's say I have A to be equal to, let's say A, B, C, and D. For me to find the inverse, I need to first of all find what the determinants, right? So I will say that A should be equal to what? AD minus what? BC. And that, for me to find the inverse of A, then it should be equal to 1 over the determinant, which is what? AD minus BC, all multiplying the interchange position of A and what? D. So we have D here, we have A, and we negate towards C, and we negate towards B. So that's what actually matrix A was before. This actually what matrix A has been converted to this inverse form. So you're going to reverse the situation, right? So meaning that 1 and 1 here was interchanged, right? So when we interchange 1 and 1, we're still getting 1 and 1, right? And here, the negative 2 here, see here was negated. The 3 and 2 was negated. Hence, the result of negative 2 and then the 3. So that should tell you that our A here, actually, our A here, we have 1 and 1. When interchange is going to be the same thing. But here, negative 2 was actually a positive that we negate, making it what? Negative 2. So it was positive. So when we negate, make it negative for 2. And the 3 here, which is positive now, was also negative. When we negate, we're getting what? Positive for 3. So you have what? Negative for 3. So meaning that our original matrix A is actually what? 1, 1, 1, negative 3, 2, what? 1. If you like, let's find, we can, when we find the inverse of it, we're going to get this back. Let's try and let's see. So for us to find this, we first of all find the determinant of this matrix. So 1 multiplying 1 minus 2 multiplying negative 3. What are we getting? We have here to be 1, negative, negative, we are getting positive. So positive 6, and we are getting what? 7, right? So what will be the inverse? And that should be equal to 1 over 7, need to bracket, or with our array. So we have 1 and 1 changing position, right? And then we negate what? Negative 2, and we negate negative 3, probably going to result to a positive. So this is the question actually that you see here. This. Hope you can see that. Yeah. So actually this is the original what matrix. So 1, negative 3, 2, and then 1. So that is that, and you're done. Very simple. So you just have to reverse everything. Question 50. Find the value of x given that we have this and that. So let's see. So here it is a matrix multiplying vector approach. So we have what? 1 multiplying x, so we get what? X, and 2 multiplying y, we get what? Plus 2y. And we have what? X multiplying negative 1, we get what? Negative x, and we have what? 1. Sorry, thank you. 1 multiplying x, we're getting x, and 2 multiplying, we're getting 2y. And here we have negative 1 multiplying x, we're getting negative x, 1 multiplying, we're getting what? Plus what? Y. And all should be equal to 4 and 5. Okay, so this is what we're going to do. We have x plus 2y, and that should be equal to 4. Equation 1. We have negative x plus y to be equal to 5. Equation 2. So once you're able to get this, here we use our calculator to deal with this. So on your calculator, you go to mode, you select 5, and you identify what? Ax plus by is equal to c. Something like this on the calculator. Okay. So once you identify this,
Hello guys, you are welcome back to Larbi Premium Consult. On this channel, we share educational content ranging from mathematics to accounting.
So let's continue. We have some interaction, so we needed to sort this out before. So let's continue. Sorry for that. So here, as I was saying, we have x plus y is equal to 4, and we also have a negative x plus y is equal to 5, right? So we just have to key in their coefficient. So back to the second equation, the x was -1 and the y was what? So y is 1, and then the c is what? 5. So once you get that, then you press your equal to sign, you get your x to be equal to what? Negative. So we have our x to be equal to -2, and we have our y to be equal to what? Positive 3. So this is how we use the calculator to solve for a simultaneous equation. You go to mode, you go to 5, you identify ax plus by is equal to c, and you use that to solve for a simultaneous equation. Okay, so you get x equal to -2, y to equal to 0.2. So now question 53. Which of the following is a causal forecasting method? Which of the following is a causal forecasting method? A, linear regression; B, exponential smoothing; C, weighted moving average; and D, moving average. So when we're talking about causal relationship or causal forecasting, then we are into what? A linear regression. So linear regression is a causal forecasting method. It's also another method of forecasting, but it has to do with the cause and effect, right? That's where we have dependent variable and then independent variable in that line. Correlation regression. So regression, linear regression. 52. In using exponential smoothing forecasting method, if you want to give more weight to a recent demand information, the smoothing constant must be close to. So we want to identify more weight on the recent data. Realize that in exponential smoothing, we said that our forecast for a particular period, ft, is always the forecast for the previous period, right? Let's say f1 plus the smoothing constant multiplying what? The forecast, the actual value for, let's say, f1 minus the forecast value of, let's say, f1. This is what we identify when it comes to the exponential smoothing. So for us to give more weight, which is the smoothing constant on this recent data, we are saying that the smoothing constant must be close to what? So for us to give more weight, it must be close to what? 1. Because when we add all the weight, it must be equal to what? 1. But for examination conditions sake, you might be given a different weight, which when you add, you're not going to result to 1. But ideally, when you add all the weights placed on the most recent data, you must get what? 1. So it must be close to what? 1. So that should be what? B. Right? So always within the range of 0 to what? 1. 0 to 1. So let's take note. So more weight means it should be close to what? 1. Question 53. Which of the following is not classified as a qualitative forecasting model? As a qualitative forecasting model. So by qualitative, that's where we have the judgmental kind of what? Some subjective view of forecasting. So we have definitely, we have view of executive opinion, we have sales force. It is only exponential smoothing, which is not part, because exponential smoothing is a quantitative method of forecasting, so it's not. Which of the following is a technique used to determine forecasting accuracy? By forecasting accuracy, we want to know the how accurate our forecasting was. So a method that we use to basically 3 for our level. We have the mean absolute deviation, mean absolute percentage error, and then mean square root error. So out of this, which of them is the one used to determine forecast? That's what the mean absolute percentage error. So the rest are different items altogether. Now, question 55. Enrollment in a particular class for last 4 semesters has been 120, 126, 110, and 130. Suppose a one semester moving average was used to forecast enrollment. Thus, the forecast for the second semester would be what? 120, third would be what? 126, and last semester would be what? 110. What would the mean square error for this situation? What would be the mean square error for this. So how do you calculate the mean square error? So in this case, we'll have our actual, right? And we'll have our forecast, and we'll have our error, right? So our actuals was what? 120, 126, 110, and then what? 130. What was the forecast for the second semester? So suppose we're using what? A one semester moving what? Average. So meaning that for us to forecast for the next, it's just one what? Data divided by what? One. All right. That is the moving average here. One semester moving average. Okay. So that one was what? So that means the second semester. So we have what? Semester. So sem. So we have sem 1, sem 2, sem 3, and sem 4. So for sem 2, it was what the forecast was what? 120. Sem 3 was what? 126. Sem 3 was 126. And then sem 4 was what? 1110. Right? So what will the mean square error be? So here we want to find what error for this. So here it is actual. For us to find error, it is actual minus forecast. You compare actual to what? Forecast. So you have actual of 120, you have forecast of what? 120. So what is the difference? Is 6. So positive is right here. We have the forecast for 120, you have the actual for what? 110. So what would be is actually what? Negative what? Negative what? What would be? It's actually negative what? 16. Okay. And then we also have the forecast to be 110. We have the actual to be 130. So the difference will result to what? 20. I hope I'm right. All right. So once you're able to get this, then we'll find the absolute. Sorry, here we have to find what the square error. So we'll bring in our error square, right? So here our error was 6. So when you square it, square of 6 is 36. Square of 6, negative 16 will result to what? 256. And square of 20 will result to what? Is it 400? Yeah, it's going to result to 400. So I don't know, they need to add all the square errors. So what are we getting? So summation of square errors. So summation of square errors should give, when you sum all of them up, you should be able to get what? 692. So therefore, our mean square error should be equal to the summation of the squared errors divided by what? The number. So the square errors was what? 692. And how many numbers are we using? That is what, from 2 to 4 is what? 3. So divide by what? 3. Okay. So what are we getting? With my case, I had what? 230.6. So in 2 decimal, we get 230.6 what? 7. That is my mean square error that I got in that line. So let's be guided about this. Question 56. Assume that you have tried 3 different forecasting models. For the first, that is mean absolute deviation was 2.5. Second, mean square error is what? 10.5. And third, mean absolute percentage was what? 2.7. We can say then, A, the third method is the best. B, the second method is the best. C, methods 1 and 3 are preferable to methods 2. And then D, none of the above. So which of them will I actually go for? So this actually is none of the above. Because why? Because we don't have any information that actually they used, or the question actually used to calculate for these what forecasting what errors. If the information was there, then we would have said that, okay, based on this information, then we can say that, okay, this method is best or that. And the question even said assume. So we are assuming. So we'll say that none of that above will be a preferable, or a way that we can say that we accept this or we won't accept that. So it's going to be what? A none of what the above. Because we don't have any information to explain the values that it was what given to us, so that we can make a perfect what decision. Because we say forecasting is all about making what decision. And we make decision based on a solid information, not any other. Even if we don't have information based on some experience by judgmental, it's also part of the information, qualitative. All right. So if you don't have information, you can't say anything about certain numbers, right? Unless you get information. 57. Daily demand for newspapers for 10 days has been as follows. So we have 12, 13, 16, 15, 12, 18, 14, 12, 13, and 15, listed from oldest to the most recent. Forecast sales for the next day using a 2-day moving average. So we have to forecast for this. So here is a 10 days information from daily newspapers, right? So for us to forecast for the next day, that's going to be what? F of what? 11. That is what? The 11th day. That is going to be the 11th day. So F subscript what? 11. Okay. Because these are newspaper from what 10 days information. So the next is going to be 11, right? So therefore, if we are using a moving average, we say that we mostly forecast using the recent information or using the recent data, and we are asked to use what a 2-day moving average. So meaning that the 2-day moving are going to be from what 13 to what 15. That is the most recent, right? So that's going to be what F of what 9 plus, sorry, I say F, A of 9, that's actual, plus A of what 10 divided by what the number, which is what in this case 2. So what are we getting? What is A? 9. A9 is what 13. That's actual data for the 9th day, plus 10, which is what 10th day, which is what 15, divided by 2. So what are we getting? We get 28 divided by 2, and we are getting what 14. So the forecast for the 11th day is going to be what 14. So let's take note. That is a 2-day moving average. As one increases the number of periods used in calculation of a moving average, A greater emphasis is placed on more recent data. B, less emphasis is placed on more recent data. C, emphasis is placed on more recent data remain the same. And D, it requires computer to automate the calculation. So what will be the answer? What will be your answer to this? Let me see in the comment section. What will be your answer to this? What will be your answer to this question? As one increase the number of periods used in calculation, then what is happening? Let's say we have what? Just two information. Let's say 20 and let's say 30 and let's say 20. It's just we are using more or less a two moving periods, and we have these two data, right? So when we add these two and divide by 2, we are getting what? Here are going to get 50, you're going to get what 25. Okay, so when we get 20, that's fine. But in a situation where, so meaning that here the weight is what 1/2, isn't so? 30 plus what 20. The weight that we place on each data here is what 1/2. But when we have data like let's say 30 plus 20 plus let's say 10 plus let's say 40, how many numbers do you have here? 4, right? So divide by 4. So mean that the way that we place here is going to be what? 1/4 on 20 plus 20, sorry, 30 plus what? 20 plus 10 plus what? 40. Is that so? Yeah. So meaning that the weight, when we have 1/2, when the number of period was 2, the weight was what? 1/2, which is what? 0.5, which is greater than what? 1/4, which is what? 0.25. So as and when you increase what? The number of periods in calculation of moving average, the weight that we place on the most recent data will become what less, because as and when the number of periods increase, the weight becomes what small. The weight becomes small. So when you have small number of periods, we get high weight placed on the recent data. But the more the weight being, the more we increase what the periods, the less we get what the weight. So here the answer should be, as and when one increase the number of periods using calculation in a moving average, less emphasis is placed on more recent what data. So we are talking about the weight. So it becomes what B. And you can see from what we're doing, 1/2 is greater than what 1/4. So as and when we increase, let's say we increase to let's say 5, it will be 1/5, which is what lesser than 1/4. So as and when you increase the number of periods, the weight placed on the recent data also reduces. So it becomes small in that line. Question 59. Enrollment in a particular class for last 4 semesters was 122, 128, 130, God doing, 122, 128, 100, and then 155, listed from oldest to what recent. The best forecast of enrollment next semester based on the 3 moving average will be. So here we have what for last semesters, right? So if you are going to forecast for the next semester, that's going to be what forecast for the 5th semester. Okay, and we are using what you are using a 3 moving what average. You are using a 3 semester moving average. So that's going to be what 3 datas, most recent data. So that's going to start from what sem sem 2, sem 3, and then sem what 4 divided by what 3. Okay, so sem 2 was what 128, sem 3 was what 100, and sem 4 was what 115 divided by what 3. So at the end of the day, you should be only add, or you should be able to get to what 383. You should be able to get 383. You should be able to get 383 and then divide by 3, and you should be able to get 127. With my case, I have 127, 2 decimal place 0.67, and you are done. So it's very simple. Question 60. Sales for boxes of elite cookies over 4-month period were forecasted 100, 120 in that line. The actuals also were given. What was the mean absolute deviation? What was the mean absolute deviation of this? So we have what the actual, we have the forecast, and we have what the deviation or the error term. So let's go back to look at the actual. So the actuals was what 110, 114, 119, then 115, then 115. Okay, and then we have the forecast to be what 100, 120, 115, and then 123. So what will be the error is the difference between actual and forecast, right? So this minus this, I'm getting what 10. This minus this, I'm getting what negative what 6. This minus this, I'm getting positive 4. This minus this, I'm getting negative, I think negative 8 will do. Negative 8 will do. Okay, so once you find that, since we are using mean absolute deviation, after finding the error, you must find the absolute values of what? The error. So by absolute, you put them in bars. Okay, so the absolute value of 10 is what? 10. The absolute value of negative 6 is 6. The absolute value of 4 is 4. The absolute value of negative 8 is what? 8. So if it is negative and you find the absolute, if it is negative, say 8, and you find the absolute, you should get positive 8. If it is positive 8, you find the absolute, it should be the same as what positive 8. So that is how you find the absolute. So once you find the absolute, you sum them up. So what are we getting? 10 plus 6 is what? 16 plus 4, 20. So 28 in that line. Okay, so we therefore say that our mean absolute deviation should be equal to what? Summation of the absolute what? Errors divided by what? N. So we have 28. How many number of periods? 1, 2, 3, 4. So we divide by what? 4. And what are we getting? You are getting 7. So that becomes the mean absolute deviation for the 4-month forecast. Use the preamble to answer question 61 to, I think we have a number of questions there. Given the following data on the number of cups of 9 crawlers sold at a local bake shop for a 6-period time frame. So question 1, we are asked to use a 2-period moving average to forecast demand for the 7th what period. So period 7. So that means that we have what? F7. And we are using what? A 2-period moving average, right? So meaning that most recent data would have to take into account this, right? That is 280 and then 310. These are the most recent data in that line. So meaning that we have demand 5 plus what? D6. So D5, D6 divided by what? 2, since we are using a 2 moving average. Okay, so what are we getting? We have here to be what? 280 plus, we have here to be what? 310 divided by 2. So in that line, we are getting what? 590 divided by 2, and we are getting what? 295. So 295 becomes the forecast for what? Week 7 using a 2 moving average. Using a 3 moving average to forecast for, so here 3, 2, so 7. So it means that we're going to consider 3 data. So from 6, 5, and then what? 4. So we're going to have what? D4 plus D5 plus what? D6 divided by what? 3. Okay, that is the weight. So in this case, our D4 was what? 255 plus 280 plus 310. Once you get the concept, we can move very fast, right? Divided by 3. Okay, so what are we getting? When you add all, you should be able to get what? 845 divided by 3, and we are getting, so in my case, 2 decimal places, I had 281.67 actually. And question 63, we are saying that if the forecast for fifth period is 275, use exponential smoothing to forecast for the period 7 if alpha is what? 0.17. So before we can forecast for week 7, we say that forecast for week 7 using exponential smoothing should be the forecast for week 6, all right, or period 6 plus the alpha or the constant exponential smoothing constant multiplying the actual, that is the demand for 6, and then the forecast for 6. But do you know the forecast for period 6 and then the actual for period 6? No, we only know the actual for period 6, but we don't know the forecast. So we need to find the forecast for what week 6. So what will be the forecast for week 6? It should be the forecast for week 5 plus the alpha minus the actual minus the forecast for what? Week 5. So let's see. So we know that forecast for week 5 has been given in the question. If the forecast for the period 5 is 275, then we have it here 275 plus the alpha, which is what? 0.7. All right. And what was the actual for week 5? And we know that to be the demand of what? 280. So bring that here minus the forecast for week 5, which is what? 275. Okay. So once you're able to get that, then we are good to go. So we have 275. When you multiply 0.7 by the difference between the two, you should be able to get 3.5. And what are we getting in total? We are getting what? 278.5. So this becomes the forecast for what? Period 6. Okay. So once you get a forecast for period 6, then we can find the forecast for what? Week 7. All right. Because we already know the actual for week 6. So therefore, our forecast for week 7 should be equal to the forecast for week 6, which is what? 278.5 plus 0.7 into bracket the forecast, the actual for what? Period 6, which is what? 310 minus the forecast, which is what? 278.5. 278.5. All right. So here we have our 278.5 plus, what is the difference here? When you do that, you should be able to get 22.05. And when we add or we are getting what? 300.55. 300.55. And you are done. If you have any question, you can drop in the comment section in the line. Then question 64. Given forecast errors 640, -2, and -2, what is the mean absolute dip? So you have been given the errors just to find what the mean absolute. So since we have the errors, so we have errors here. So what we need to do is find what the absolute of the error, since we are dealing with mean absolute deviation. Okay, so we have what? 6, 4, 0, -2. So what will be the absolute of 6? It is 6, 4, 4, 0, 0, -2, 2. So we just have to sum them up. What will be the total summation of the absolute of the errors? 6 plus 4 is what? 6 plus 4 has to do with what? You get 10. Then 10 plus 2. 10 plus 2, you are getting what? 12, right? So that means that we have here to be 12. That means that we have here to be what? 12. So therefore, our mean absolute deviation should be equal to what? The summation of what? The absolute values of the divided by what? N. So we have 12 divided by what? 4. And we are getting what? 3 as being our mean absolute deviation. So let's take note. Given the forecast errors of 6, 4, 0, and -2, the same from what is the mean square? So here, all I want to do is to create what? A square error. So square of 6 is what? 36. Square of 4 is what? 16. Square of 0 is 0. And then square of 2 is what? 4. So you just have to sum them up. So 36 plus 16 plus 4, what are we getting? Let me chip in normal mode. So we have 36 plus 16 plus 4. we are getting what? 56. Getting 56. So that means that here our mean square error is going to give us what? Summation of what? The square error divided by what? N. So we get what? 56 divided by what? 4. And we are getting what? In my case, I had mean square error to be what? 14. And you are done. Very simple. So you must have the formulas at heart. Then question 66. Dash moving averages react slowly to a recent changes than dash moving average. So what do you think is going to be the spaces? I will leave for you. I want to see your answer in the comments before I come back to give you the answer to this. I want to see your answers in the comments before I come back to see your answers to this, to see if you're actually right. Then 67, dash method assume that what has occurred in the past will continue to occur in the future. For this, I'll give it to you. It's called time series. Time series. So if it is actually, it rains today, or let's say it rains tomorrow, the probability that it might rain the next day or a 2 day to come is what? Is possible. So that's time. So time series is a method that actually make an emphasis of what? An event that has occurred in the past for which is certain to occur what? In the future. So time series use what? Historical data to make predictions for the future. So it assumes that what has occurred in the past will continue to occur in the future. If somebody dies today, the possibility that tomorrow somebody will die also what? Possible. If somebody was get richer today, the possibility that somebody also will get to rich the next day is also what? Possible. That is what time series is all about, right? So it's time series actually. But since this is, let me see your answer before I come back to it. What would be? Okay, so here, let me put the answer there so that we can go. Dash moving average we are slow. So here is what? Longer moving averages react more slowly than changes that will occur in the shorter what moving. So it has to do with the longer and shorter, right? This has to do with where we are talking about what classification of what forecasting based on what their time horizon. So if you forecast for a longer period, the chance I may react to an information in the market, right, is slowly because it takes time for that decision to come to pass. But if you have a shorter decision or shorter forecast, the more we can get an information in the market is very what sharp because it is a short duration forecast or short duration decision, and that can get adjusted to the information within the market. So that is the difference. So longer moving average forecast reacts slowly to a shorter moving average. So let's take note of that. So shorter. So here's also time series. Then sales for boxes of Girl Scout cookies over 4 months were forecasted as follows. So we have 100, 120, 115, and then 123. And we also have the actuals. So we're asked to calculate what was the mean square error for the 4 months. So the mean square error, we need to find the errors, right? Okay. So we have what? The actual, we have the forecast, we have the error, then we have the error square. So the actual was what? What was the actual? The actual was what? 110, 114, 119, then 115. Then the forecast is 100, 120, 115, and then 123. So what will be the error? So the error is the difference between actual and forecast. So here is going to result to 10. Here is going to result to -6. Here is going to result to +4. Here is going to result to -8. So square of 10 is what? 100. Square of -6 is what? 36. Square of 4 is 16. Square of 8 is 64. So you just have to find what? The summation, right? Of these square what? Values. So when you find the summation, when you find the summation of these square errors, you should be able to get, in my case, I had what? 216. So therefore, our mean square error should be equal to the summation of the square error divided by what? The number. So we have what? 216 divided by what? 4, right? So what are we getting? You should supposed to get what? 54. That's what I got in that case, 54 in that line. So let's take note. Question 69. Consider the following demand and forecast. So we have period, demand, and forecast. So it says that if the mean absolute deviation for the 4 periods under consideration, what is the forecast for what? Period 4. What is the forecast for what? Period 4. So what will be the forecast for period 4? Let's see. So we know that the mean absolute deviation deal with what? Errors, find the absolute values of what? The errors, and then you find that. So we already know that to be 3. So MAD to be what? 3. So therefore here, based on this information, let's find our error. Then we find absolute of the errors. So forecast, actual, and then forecast, right? So here you're going to get what? -3. Here we are getting what? -3. So here we are getting what? -2. Okay. So we want to find it. So this should be x. So here it should be what? 22 minus what? X. Because we don't know. So that should be 22. So that should be 22 minus x. So we find the absolute value of -3. We are getting 3, here 2, and here getting 22 minus x. So that you sum them up. So we have 3 plus 3, we are getting 6, plus 2, we are getting what? 8, plus 22, we are getting what? 30. So mean that our total sum is what? 30 minus what? X. So therefore, our mean absolute deviation should be equal to what? 30 minus x divided by what? 4. Okay, but we know mean absolute deviation to be what? 3, right? So we have 3 to be equal to 30 minus x. 30 minus x divided by 4. Here is out of 1, so cross multiplication. So 4 multiplying 3, 1 multiplying 30 minus x. So you're going to get what? 30 minus x to be equal to 4 multiplying what? 3. So what are we getting? We have 30 minus x to be equal to what? 12. So therefore, we have 30 minus 12, and x will take the position of what? 12, and we are getting what? 18. So therefore, x equal to what? 18. X equal to what? 18. That's the forecast for what? Week 4. So let's take note. Question 70. Daily demand for newspapers for the last days has been the following. So for the last 10 days has been the following. Listed from oldest to forecast sales for the next day using what? A 3-day weighted moving average, where the weights are 3, 1, and 1. This is what I was saying. That all things being equal, expect the weight to always be what? When you sum them up, it should be always what? 1. But for mathematics and for examination purposes, at times the examiner might actually give you any weight at all. For once you're given the weight, just use the weight and you are good to what? Go. So you ask to forecast for the next day. So that's going to the 11, right? Since this is a 10-day information, using the weighted moving average, where we have what? 3, 1, and 1. So the most recent data is going to receive what? The highest weight. So since you are using a 3-day moving average, that's going to take into account 15, 13, and then 12. So we're going to have here to be what? Days, number of days. So we have D to be, so we take from 8, D to take from what? 9, plus D to take from what? 10, right? So here we have weight, the highest weight, I mean, in that order. Okay, so let me not even bring that. Let me make it like this. So f of 11 should be equal to, here the highest weight will apply on the most recent, which is what? 15. So we have what? 3 multiplying 15. Okay, then the next one, 1 multiplying what? Demand 9, which is what? 13, and then 1 multiplying what? 12, again, which is what? 8. So what are we getting? We have here to be 45, here to be 13, here to be 12. When you sum them up, you should be able to get what? 70. So this is going to be the forecast for the 11 using this weight in that line. Okay, so let's take note of that. Question number 71. Given that dy over dx is equal to what? 4th root of x plus cube root of x minus 1. Find the expression for y in terms of x. So here it is just an integral, right? So I have to say that the integrate of what? Dy over dx, and we have what here too. Remember, cube 4th root of x can be written as what? X to the power 1 over 4. X to the power 1 over 4. Then here it can also be written as x to the power 1 over 3 minus 1. Okay, or dx. Okay, we also have dy over this, so no need for this. So when I integrate dy over this, I'm getting y. So if I also want to integrate this, I'll add 1 to the 4 and then divide. So what am I getting? So in this case, it becomes what? x1 over 4, x1 over 4 plus 1 divided by, so when I add 1 plus 1 over 4, you should be able to get what? 5 over 4. So I divide by 5 over 4 plus here to 1 over 3 plus 1. With that one, I'm also getting what? Divide by 4 over 20. I should be able to get 4 over 3. Then minus here, integral of 1 should be fetch me x. Then since an indefinite, bring in what constant, say k. Okay. So therefore, in simplifying to the more simplified term, here you can find the reciprocal of this fraction. That's going to result to what? 4 over 5. X to the power 5 over 4. And here too, you're getting 3 over 4, x to the power 4 over 3 minus x plus what? K. Very simple, actually. They are not difficult. So just add whatever you get, you divide by the result, and you are good to go. 72. Identify which of the following statement is correct. This one too was erased. I don't know why I typed them and then it didn't appear there. Okay. 73. Determine this. So we are asked to determine the value of what? Y based on this. So how you go by this? So what I want to do is to integrate this. So when I integrate 16, let me zoom it so I can see. When I integrate 16 s cubed, what am I getting? So here it should be what? 16 s cubed plus 1. So what are we getting? 4 divided by 4. Okay, plus 5s squared plus 1. I'm getting 3 divided by 3 minus. Remember, this 3 over what? S cubed can also be written as what? 3 x to the power negative 3, right? So I'll just have to what? Add 1 to this. Negative 3 plus 1, I'm getting negative 2. So I'll divide by negative 2. Okay, plus here to have 7x to the power of 1 plus 1, I'm getting 2. Then in integral of 7, I'm getting what? 7s. Since this is an indefinite, we introduce constant, say what? K. Right? So therefore, we say that we'll have what? 4x to the power 4 plus 5 over 3 x to the power cube. Then here is negative, negative, making it what? Positive. Negative, negative, positive. Negative, negative, making it what? Positive. So you're getting what? 3 over 2 x to the power negative 2 plus 7 over 2 s squared plus 7x plus what? K. Integration. Very simple. Then question number 74. We have what? This. So we have to find actually, so here more like what? Y. We have to find what? The value of y. Okay. So here, here's what we want to do. We will say that here we can write this as what? 3s squared. For the sake of this, we have to bring in this. So here it becomes s squared, and this is a cube root that will multiply the 2. So it makes it what? Multiplying what? 1 over 3. That's 1 over 3 multiplying 2 plus what? 13x to the power negative 2. This is also fine, so no problem with that. dx. So we'll have 3s squared plus x to the power 2 over 3 plus 13x to the power negative 2 or dx. Okay, so in this case, we have to integrate this function, right? So the integral of 3s squared, what are we getting? So we have 3s squared plus 1 divided by what? 3. Then we have what here to be what? 2 over 3 plus 1 divided by, so 2 over 3 plus 1, when we add the 2, we should be able to get what? We should be able to get 5 over 3 divided by 5 over 3. Then here too, you have 13x to the power negative 1 plus 1 divided by, so here negative 2 plus 1, I get negative 1. Okay, since an indefinite integral, we introduce constant, say what? K or C or any constant you want to introduce. So what are we getting? We have x cubed, right, plus, so you find the reciprocal of 5 over 3, we are getting what? 3 over 5 x to the power 5 over 3 plus, so here, since here is negative, going to result to negative, going to affect it, so making here what? Negative. So we have negative 13x to the power negative 1, okay, plus what? K. Even this, we can write this as what? s cubed plus what? 3 over 5 x to the power 5 over 3 minus 13 over x. Because we said if I have 1 over x, the same thing as what? X to the power -1 in an exponent form. Plus what? K. Plus k. So let's take note of that. Then 75. Given that the y over the x is equal to 4x cubed plus 9x squared plus 5x, where x is equal to 10, y is equal to 10, find the expression for y in terms of what? X. Find the expression for y in terms of x. So here too, we need to integrate, right? So this is what we're going to do. We'll bring in the y over the x here, and we'll bring in our 4x cubed plus 9x squared plus 5x plus 5x. Okay, so when I integrate the y over there, I get y. Just reversing everything back to its original form. So the integral of this is 4x to the power 3. Just add 1 to the power, divide the result of the power, the addition of the power, which is what? 4. Okay, so we have 9x squared plus 1 divided by what? 3. Okay, then we have here to be 5x to the power of 1 plus 1 divided by 2. Saying this an indefinite integral, introduce a constant, say what? K or C. Okay, so at the end of the day, we'll have our y to be equal to what? 4 cancel 4. We are getting x to the power 4. We are getting here to be 3x cubed. We are getting here to be 5 over 2 x squared. We are getting here to be c. But we are asked to find the value of y in terms of what? X. So we need to find a way to get rid of what? The c. Okay, that's why we're giving these values. Okay, so when y is equal to 10, x is equal to what? X is equal to 2. Okay, so this is what you're going to do. You just have to bring in your calculator here. Help you to get this done. So this is what you're going to do. You have alpha x. Get this function in your calculator. Alpha x. So alpha x to the power what? 4 plus 3 alpha x to the power 3 plus 5 over, let's see, 5 over 2 over 2 alpha x to the power 2. Then, so once you get this, that's fine, because that's where we're going to substitute the value of what? The value of x equal to 2 in there. So once you get it, just press solve and you type in 2. Then you press equal to sign. And here you should be able to get to what? 50. So I had 50 when I substitute 2 in there. So meaning that the whole of here, when you substitute 2, should be what? 50. So I know my y to be 10. So therefore I have 10 to be equal to 50 plus what? C. In an MCQ type relation, this is how you need to work so that you save time. So therefore, our C should be equal to what? 10 minus 50, and we are getting C to be equal to what? -40. So therefore, the expression for y in terms of what x should be. So that should be y to be equal to what? X to the power 4 plus 3x cubed plus 5 over 2 x squared minus what? 40. So this is going to be an expression for y in terms of what? X. And that brings us to the section on quantitative methods in relation to that. Let me see some questions. If you have any questions, you can drop in the comment section so that we'll see. Kwakwa someone is saying that please, question number 16, the answer was supposed to be 20,000 and not, okay, let's see. Let's go back to question number 16. Question number 16. Question number 16. Question number 16. Where is it? It's supposed to be what? 20,000 or 29. How is that possible? By what metric? Because we're able to calculate our revenue function, we're getting what? 300x minus x squared. Okay, and our cost function too, we also had, okay, here because there wasn't any issue about cost. So revenue. So when you substitute 100 into 300x, you are getting what? 30,000. And when you substitute 100 into x squared, we are getting what? 1,000. So the difference should be 29,000. It is 1,000, not 10,000. It is 1,000, not 10,000. Because when you square, oh, let's see. Okay, let's see. Square of 100. Okay, you had, okay, I think it's true. You're going to get 10,000, right? Not, okay. So square of 100, yeah. You get 10,000. Okay, I think it's right. You get 10,000. Okay, that's fine. Thank you for that. So you get 10,000. So 10,000 from 30,000, you get 20,000. Okay, that's fine. Good. So thank you for the correction. I think that's fine. I thought it was 1,000. I thought it was 1,000. Okay. Any other? Any other question? So in absence of any question, thank you so much for watching this video. Please do well to rewatch so that where you didn't actually get it or where you want to get more understanding, you can actually get it so that it can help you for any examination actually you may encounter in the future. Okay. So thank you so much for joining us today on this section. And I will see you all the best in your future examination that you may write concerning quantitative methods. All the best, and I'll see you next session. Bye bye. If you haven't liked the video, do what to like before you leave and subscribe to the channel so that we can regularly visit the channel for more content. So thank you and have a nice day. Bye bye. Yeah.